In the year 2000, Awqaf South Africa was pioneered as an institute of Waqf and the empowerment of communities. South Africa faces a diverse set of challenges with a high unemployment rate and a stark divide between rich and poor, where electricity, hospital care and water shortages plague communities and where lack of education hinders progress. Awqaf South Africa is a catalyst for change. As a charitable endowment receiving organization, Awqaf invests endowment funds wisely and ensures that only the income generated from investments is used to fund a variety of community development projects. We are excelling in all that we do with the highest standards of ethics, integrity, and sincerity of purpose. From masjid development, imam empowerment to sports development, orphan support, food security, and surgery support, Awqaf South Africa is paving the way by investing in the future of communities and uplifting generations to come. Awqaf South Africa, creating a legacy of hope and
A warm welcome to one and all. Welcome to Awqaf SA's Grade 11 Maths Workshop. This is hosted by Awqaf South Africa in association with the Department of Basic Education, the third Awqaf iSkill, and we're coming to you live from the Al Falah College in KwaZulu-Natal, Durban, where we have Principal Zafar Ahmed is on standby, as well as Mr. Khota, the facilitator, who will be taking you through the Awqaf SA Grade 11 Maths Workshop. Will be focused on Maths Paper 2, a very important part for your examination preparation. Mr. Khota will be focusing on past examination papers. Please let us know in the comments from where you are connecting to us from which school you are connecting to us from which province, and please do us a favor. We 20 subscribers short of 7,000. So kindly do subscribe to our YouTube platform and you will be informed of our up and coming workshops that will be taking place in October. So good morning, goeiemorgen, namaste, and assalamu alaikum to one and all. Please let us know in the comments what you thought of Maths Paper 1 session, if you derive benefit. And now we're going to be calling on Mr. Zafar Ahmed. He is the principal at Al Falah College. They have got a cohort of 400 learners that's been bussed in for this session. And he has been a very key part of this project since inception. So we'll call on him and he'll give us a introduction. Let's call on Zafar.
Good morning.
Let's give it a moment.
And many more that are streaming on our live YouTube channel. I trust you had an excellent, fun-filled, fantastic day yesterday, and we look forward to another day of exhilarating mathematics. Our contribution to preparing you for the upcoming control test or examinations you'll face towards the end of this term, inshallah. I also want to acknowledge and thank Hasanain, sitting in Cape Town at our studios, Mr. Katrada, Mr. Kathri, who's here from the sound and coordinating all of our streaming. He's been an instrumental partner in all of our previous broadcasts as well, and it makes it possible to bring this to all of South Africa. If you've missed anything, you can go back and watch all of this on the YouTube channel. And I trust that you would have had a great day yesterday, and we look forward for you to benefit from one of the leading maths tutors in this country, Mr. Khota. We're indeed very, very fortunate that we have someone of his caliber available to travel all the way from Johannesburg to be with us in Durban today to share his expertise with us here in Durban, live in this audience, but also over YouTube. Now, I know when I was growing up your age, we used to follow a legend who used to teach mathematics and physics on SABC, Mr. William Smith. Sadly, he passed away at the age of 85 during the course of the week, and many of us that were growing up at the time benefited from the tuition he provided through SABC and the TV channel. And there's been a vacuum in South Africa since he stopped teaching, and I think Mr. Khota is walking in his path and is making that type of contribution and will be a legend to fill that gap in the market, inshallah. And I think we are blessed that we have the opportunity to have Mr. Khota work with us. So in conclusion, I would hand over back to Hasanain in the studio, and we'll play a short tribute to a legend who contributed to maths and physics teaching. And I know there are thousands of people who are professionals today benefited from the tuition provided for by Mr. William Smith. And no doubt, some of you will go on to do great things in your journey for mathematics and the tuition you would have got from Mr. Khota. I wish you well for the next day and trust you have a wonderful day, and I wish you well in your upcoming examinations as well. Thank you. Good afternoon, good morning. Enjoy the rest of the day. Assalamu alaikum wa rahmatullahi wa barakatuh.
This week we say goodbye to a true pioneer in education, a man who transformed the way mathematics was taught and understood by millions, William Smith. William Smith was the face and voice of the SABC2 Learning Channel, where he brought maths tuition to every home in South Africa with his passion for teaching and his clear, engaging style. He helped countless students conquer the fear of mathematics. Many who struggle with mathematics found a guiding light in William Smith's teachings. His work empowered students to overcome challenges, achieve academic success, and pursue careers they once thought they were beyond their reach. At Awqaf South Africa, we are inspired by William Smith's dedication to education. We continue his mission to empower learners across the nation with our maths upgrade programs, ensuring a bright future for the youth of South Africa. Rest in peace, William Smith. You served your country with distinction. Your legacy will continue to inspire and uplift generations to come.
So there we go. That's our tribute to William Smith. And here at Awqaf, we will continue to provide support to the learners of South Africa so they can be well prepared for the examination. So I'm going to be calling on Mr. Khota. He's going to be doing all of the talking during the course of the day. He'll be the facilitator. And please keep that comments going. Khalid is with us, and he will be flighting some of that comments on the screen. We'd love your engagement. So to kick off our session, we are going to be boarding the Awqaf SA Maths rocket. So we're going to be queuing in Mr. Khota's launch sequence, and then we'll bring him onto the session. So let's cue Mr. Khota's launch sequence. We are all going to board the Awqaf SA Maths rocket.
Eight, seven, six, five, 3, 2.
And we have lifted off. Mr. Khota, take the picture. Wait.
Assalamu alaikum and good morning, South Africa and all our learners. I just want to say thank you so much for all the positive feedback that has come through yesterday. And we had an exciting bumper day yesterday. Our onliners enjoyed it. We saw all the comments that were coming through. And yeah, we've got an exciting day for paper 2 that will be taking place today. Remember, we're doing analytics. We are doing analytics, we're doing trigonometry, and we are doing Euclidean today. So without any further delay, I just want to thank Brother Zafar Ahmed from Al Falah, Hasanain from Cape Town, for putting a program like this together so that we can take South Africa to the next level. So, welcome back everybody. I hope all our onliners are all excited. Everybody is ready. You got your hydration, your stationery, your exam pads, your scientific calculators, and you are ready for action. So I just want to open up the chats. Let's see if we got all. Good morning. Ocean's Leadership, Spesile Samuel Kumalo, you're on your way. Siabonga Secondary School. Good morning everybody. Keep your comments coming. We'd love to interact with you. It doesn't mean that we are beaming from KwaZulu-Natal. We don't see you. The minute you put up your comment, we will be responding to you. So guys, let's get started with today's program. We are starting, welcome back grade 11s. Let's start with analytics. Now, under analytics, you're going to get 2 questions. So let's look at paper 2. Put the heading there, paper 2. Put the heading paper 2. Now, under analytics, you're going to get 2 questions. Plus minus 35 marks in your final exam. 2 questions, maybe one for 17, one for 18, probably between 30 and 40 marks. It might even go up to about 40 marks. And this is easy. Then you got trigs. And that is also easy, but you need to follow. So I'll show you how to master that. Then we have what we call trig graphs. And then you've got 2D trigs. And then you've got circle geometry. So I have data handling. Data handling is very easy. Statistics, your mean, median, mode, box and whisker diagram, ogive curves, standard deviation and variance. That's another 20 marks. So there we go. We're starting off with analytics, guys. And the first thing we need to know are what are our tools? What are our formula for analytics? So the first formula that we need to know for analytics is our distance formula between 2 points. We're always working between 2 points. So the distance A and B, by now you should all know that, minus x1 all squared plus y2 minus y1 all squared. That to prove shapes, to calculate distance, and to calculate the area of triangles. Number 2 is the gradient formula. Very important formula. We all know that. The m of AB is equal to y2 minus y1 over x2 minus... For parallel lines, to prove 2 lines parallel, we know the gradient of line 1 is equal to the gradient of line 2. For perpendicular or for 90-degree lines, the m of line 1 multiplied by the m of line 2 must equal to -1. The angle of inclination, we know that tan theta or alpha or beta, tan theta is equal to the gradient of the line. So we got parallel lines, we got perpendicular lines, we got the angle of inclination. We use it for collinear to prove points are in a straight line. Collinear means if you want to prove that A, B, and C are in a straight line, then the gradient between A and B must equal to the gradient between B and C. Then they will be in a straight line. Right. We then have the midpoint formula. We got 2 more formulas, guys. 2 more formulas from a past paper. And how easy is it? This is where you're going to bank marks. This is where you are going to score your marks. So we got the distance. I'm just going to quickly go through it. We got the distance formula. There we go. We got the gradient formula. There we go. We now have the midpoint formula, another very important formula. We know the midpoint of a line is x1 plus x2 over 2, y1 plus y2 over 2. Some of you make a mistake in that. You get it wrong. And we have our final formula, the equation of a straight line. Y is equal to mx plus c. And if the gradient and a point is given, if the gradient and a pair of then we can use the formula y minus y1 is equal to m into x minus x1. you to y is equal to mx plus c. The four big formulas that we are going to be utilizing in order to crack and to master analytics. Like I said, 40 marks for Mahala. It's really easy. It's really easy. All you have to do is substitute, use the right formula, substitute, use your calculator, your laws of equations, and you're going to get the right answer. How's our onliners doing? Good morning, Marius Dupree from Belgravia School, Cape Town, Khota High School. Good morning, everybody. Hello, South Africa. Hello, the world. Amazing. I think we had about 8,000 or 9,000 learners yesterday. And I'm sure we're going to have much more today for paper 2. And this is such an amazing feeling that we are all together. This is one big study group, the whole of South Africa studying together for a common goal and for a common purpose. So well done. Kudos to you. 10 brownie points for you. Right, let's start. Let's take an exam model and let's apply this formula. We're going to do 2. I'm going to do 1. I'm going to create 1 for you now. I'm going to make 1 up for you now. And then we're going to take last year's final exam. We're going to apply it and we're going to get full marks. Total. Right. So to show you how it's done, very simply, I'm going to clear the frame. I hope you all got this down. And if you haven't, if you're sitting at home, and if you feel that your handwriting is a bit slow, or maybe we're moving through the slides a little too fast, then take a screenshot of it and you can always take it down afterwards. Remember, this is also recorded and it's on the YouTube handle on Awqaf SA. You can go to YouTube and you can re-watch these programs. So as long as you understand these formula, you memorize the formula. I'll show you how to apply it now in the exams. Onliners, are you ready? Take a deep breath. We're about to go deep sea diving. We're about to swim with sharks. Right, let's go. Let's go. I'm going to make 1 up for you and let's do 1 together. So I tell you, let's take this one down. Take this diagram down with me. Guys, I'm making it up. As we're sitting here, I am making it up. So I'm going to give you point P. Let's choose any value, minus 10 and 20. Is your y-axis, that is your x-axis, that is point Q, that is point R. Point Q, I tell you, minus 6 and minus 12, and I tell you R is 8 and 2. Now there's a reason I chose different values so that when we do our substitution and you're practicing, you know exactly which values go where. Right, I'm going to call this angle theta. And I'm going to call this angle here angle beta. And we're going to call this point point T. Okay, so here we go, guys. That's your y-axis, that's your x-axis, that's 0. These are your points, point P, Q, R. The first question, I want the gradient of PQ. Find the gradient of PQ. Now, this is easy work, guys. If you guys fail this, honestly, don't do math. It's simple, straightforward. The question tells you, find the gradient, so it tells you which formula to use. So now we're going to say the M of PQ is equal to, please, because they're asking you for the gradient, write your formula. You get a mark for it. PQ, I can call this one X2, Y2. I can call that one X1, Y1. So Y2 minus Y1, 20 minus 12, plus 12. Over minus 10 plus 6. That will equal to 32 over negative 4. That is equal to minus 8. So the m of this line is equal to negative 8. Easy, your first 3 marks, guys. Your first 3 marks. What do you think the next question is going to be? You can already anticipate the questions. What do you think the next question is going to be? Find theta. Why did they ask you for the gradient of this line? Probably to find angle theta, am I right? So question number 2, find angle theta. Let's see you this one out on your own. Find theta, the angle of inclination. So we're going to say tan theta is equal to the m of line PQ. Tan theta, we always use tan, we don't use cos. So tan theta is equal to negative 8. Theta is equal to shift tan negative 8. I get minus 82,87. If they say round it off to the nearest angle, so minus 83 degrees. Now be careful. Pay attention. Theta is an obtuse angle. It's greater than 90. So we say therefore theta is equal to, this angle here is acute. If we ignore the negative, 83 is acute. So how do I get an obtuse from an acute or an acute from an obtuse? I say 180 minus 83. So 180 minus 83 gives me 97 degrees. So there we go. We got angle theta equal to 97 degrees. Okay. Let's put the next question down. For those of you who have taken this one down already, question number 3. I want an equation of a line perpendicular to PQ passing through let's say the midpoint of PR. Now this question is worth 6 marks. This question is worth 6. The grade 12 workshop links was last weekend. And that one was from Cape Town. But it's up on YouTube and it's up on the Awqaf SA website. Amira from Pumalanga says in grade 12, thank you so much for the lesson. I'm writing math paper 2 tomorrow. I watched both paper 1 and paper 2 videos and it really helps. So thank you so much. Right, let's do this. The important words here, equation. So you know equation is y is equal to mx plus c, yes or no? The next important word, perpendicular to PQ. passing through the midpoint of PR. So what's the first thing we need to do? Find the midpoint of PR. The midpoint of PR. So the midpoint of PR, there's a lot of work that needs to be done here. The midpoint of PR is going to be x1 plus x2 over 2, y1 plus y2 over 2. So minus 10 plus 8 over 2, 20 plus 2 over 2. That will give me minus 2 over 2, and this will give me 22 over 2. My midpoint is at minus 1 and 11. So the midpoint of this here, the midpoint is actually there, it's not t. So that part there is equal to that part there, and that one's coordinates is minus 1 and 11. Now they want the equation of a line perpendicular to PQ. So the m of PQ was equal to minus 8. Therefore, the m of the perpendicular line is equal to 1 over 8. Why? Because the m of line 1 multiplied by the m of line 2 must equal to minus 1. Flip the fraction. What do you do? So if this one is negative, this one will be positive. If that one's 8 over 1, this one will be 1 over 8. So you change the sign and you flip the fraction. Number 1, that was step number 2, that was step number 3. Now we want the equation of a line. So the equation of a line is given by what? Y is equal to mx plus c. So now I'm just doing it here on the top. I'm just moving up to the top of this question. Therefore, y minus y1 is equal to m into x minus x. So now y, which point must I use? Negative 1 and 11. So y minus 11 is equal to 1 over 8 into x plus 1. Now let's bring this in the form y is equal to mx plus c. Y minus 11 is equal to 1 over 8x plus 1 over 8. And your final answer now, take the 11 on the other side, your final answer coming up, y equals 1 over 8x plus 11. 1 over 8 plus 11 gives me 89 over 8. And this, boys and girls, is our final answer of an equation passing through the midpoint of PR. Are you all with me? It's done in how many parts? 4 parts. So we had to find the midpoint. We had to find the midpoint. We got the gradient. Now we find the new gradient of the line. We take that, we put it into y is equal to mx plus c, and you get your final answer. You get yourself 6 marks for that. Okay. Onliners, how are we doing there? Sipesile says, thanks for the lesson, Kwama Khota High School from Sifiso Kuzwayo. Hand pink waving. Well done. Welcome, welcome, welcome all. Welcome all. We love you lots and we want to see you all perform. At the end of the year, we want you screaming for joy. When I see you again next year, God willing, we say inshallah. Next year in grade 12, we'll be sitting here again and you'll say, yo, say, we came last year for grade 11. We all got 90%, 100% for mathematics. Say Ameen. Say Amen. Amen. Lovely. MashaAllah. Right. Let's give you another question. Let's wrap this one up before I go into your fine PQSR. Okay, so let's do this. Question number 5. If S, X, and Y is a point in the 4th quadrant, find S, X, and Y. Find the coordinates S, X, and Y. If PRSQ is a rhombus. For 5 marks. Remember, we must still find angle beta here. We still need to find angle beta afterwards. In fact, that will be our next question. That will be our next question. So we're on question number 5 here. So it's a point here. There we go. So let's put the point somewhere there. S, X, and Y. Obviously, PQ, let's do that, and let's do that. If S, X, and Y is a point in the 4th quadrant, find the coordinates S, X, and Y if PQSR is a rhombus. Now we also know in a rhombus that the diagonals, listen, we know that the diagonals bisect each other. So what you do here, guys, use your midpoint formula. Because the same midpoint of this line is the same midpoint for that line. So to answer this question, I'm going to start here on the top because of space. And we're going to find the midpoint of QR. What are we going to do, boys and girls? Find the midpoint of? Right, so let's write it. Midpoint of QR is x1 plus x2 over 2, y1 plus y2 over 2. QR, so it's minus 6 plus 8. Minus 6 plus 8 over 2. And then y1, that's negative 12. So y1 plus y2 over 2. And that would give me 2 over 2. And that would give me minus 10 over 2. And that would give me 1. And that would give me negative 5. So this negative 5. Now we need to find the coordinates of S. It's the same. Pay attention. This is our midpoint. So now you say X for the coordinates of S. X x midpoint is equal to x1 plus x2 over 2. Y midpoint is equal to y1 plus y2 over 2. What's your x midpoint? 1 is equal to x1, which is x, plus x2 minus 10 over 2. Y midpoint minus 5 is equal to y1, which is y, plus 20 over 2. Now this is an equation. All we have to do is solve for x and y. Times 2 times 2, 2 equals x. So x will equal to 2 plus 10. What is 2 plus 10? 12. Very good. Multiply this side by 2. Multiply that by 2. What am I left with? Minus 10 is equal to y plus 20. Y is equal to minus 10 minus 20 is how much? Minus 30. Very good. And there's your final answer. S 12 and negative 30. Don't, or equations of straight line. You can, but it's long. This is the best way to do it, the shortest way to do it. You'll always get your answer correct. Use your midpoint formula, especially for parallelograms. So you can write this little rule down somewhere that for parallelograms use, let's write it here on the top. Let's write the rule here on the top. For palms, when x and y, to find x and y, use the midpoint formula. What are your parallelograms? Sorry, actually for quadrilaterals, not, not all for quadrilaterals, for palms, for parallelograms. Square, rectangle, rhombus, and normal parallelogram. Use your midpoint formula to find x and y. Onliners, how are we doing across the country? Right. Now here's another heavy question coming up for 8 marks. This is Shimora from Kwama to comprehend. You are the best teacher I ever. Hey, thank you, thank you, thank you. Lots of love here from Awqaf and Al-Falah. Let's go, let's go, let's go, let's go, let's go. I hope you got this. Here comes the next question, guys. I hope you're ready for it. It's a bit of a cracker. Find angle beta. It's the area of triangle PQR for 8 marks. So this is your last question to wrap this up. Your killer question. What number was this? We did 5 questions. Is this number 6? Right. So here goes. Find angle beta. And hence, so that means, and so find angle beta and hence the area of triangle PQR, and hence the area of triangle PQR for 8 marks. Use a little bit of trigonometry. You got point at this juncture, you have all done trigonometry. You know area is half of a side times another side for a non-90 degree triangle times sine of the included angle. I'm going to leave you to do this one. I'm going to give you 2 minutes to try and figure this one out. This is your big question. Now, if this whole block of questions was worth 20 marks, this was 8 out of 20. Now, 8 out of 20, if you lost 8 marks, this is 40% of your entire question. One question being 40% of your entire marks for analytics. So if you get this one wrong, if you get this one wrong, only got 60% for the question. Let me see here.
White thing here, can we make that to fill this whole screen? Because we see all this.
Check. Yeah, but now I can't get, I think that's okay. Is that better? No. No, I can't go on here. Whoa. Okay, I'm just checking something here. Okay, but I'm just seeing now, how do I get back to the previous? Okay, I did something crazy here. Where? No, I'm still not there. Let me just go escape. Ah, there we go. There we go, there we go, there we go, there we go. All right, let's go, let's go. Right. Let's check this, guys. I hope you're winning here. Let's check our comments that have come in. Marvelous Cheese Ceremula. Your name is Cheese. You must be a mouse. Let's go, let's go, let's go. All right, now pay attention. Pay attention. Now there's a lot of work that needs to be done here. So the first thing that we do, we know this 97 here is going to equal to that angle plus that angle there. Watch here. I'm going to highlight something for you. Pay attention here. Boys and girls, pay attention here. So I'm doing that. I'm doing that. And I'm doing that. So this means that this triangle here at the bottom, exterior is equal to the sum of the interior opposite angles. Yes or no? So that means I'm going to find this angle first. If I find this angle, then that angle and that angle is vertically opposite. Yes or no? Then I've got a triangle. Then I can say exterior angle is equal to sum of interior. Then I will find angle B. After I get angle B, I need to find the length of PQ, find the length of QR, and use the area formula from trigonometry. Are you listening to me? So the first thing that we need to do is find this angle here. So we're going to say R, okay, if you want to call this angle alpha. If you want to, let's call this angle alpha. So tan of angle alpha is equal to the of RQ, or R. So tan of angle equal to y2 minus y1 over x2 minus x1. Let's all do this together. That will give you negative 14 over minus 14. Wow, what a brilliant question, and it worked out perfectly. We made it up. God loves us. Minus 14 over minus 14 is 1. And this is exactly what an exam question would look like. I made up all these values and it worked out perfectly. Wow. Wow. So that means, and really this is the type of question they'll ask you because that's a special angle. So tan alpha is equal to 1. So alpha is equal to your special angle 40. So this angle here is 45. And that angle there is 45. They are vertically opposite. Therefore, angle theta is equal to angle beta plus alpha. Theta, we worked it out in our previous question, 97 degrees, is equal to beta plus alpha, which we just worked out now, 45. So beta is equal to 97 minus 45, 52. So beta is 52 degrees. Question. Grade 11s, are we done with the question? No, we're not. What do we need to do? Find the length of PQ. Because we need to find the area. The question says find the area. So find the length of PQ, find the length of QR. We're getting to the answer. This is all developing. This is like a game of chess. It's like a game of chess. You pull out the pawn. You play the knight's gambit or the queen's gambit. The Bulgarian gambit. You pull out the pawn. He plays the pawn. He becomes the copycat. Kill the fatty. Pull out your pony. Bring the dummies out. The queen dies, the king cries. That guy is classic. But anyway, we are developing our chessboard in mathematics. Mathematics is mental chess. Right, now we need PQ. So PQ is equal to the square root. Let's take that out. You bring out the pony. Take that dummy. PQ. PQ. Right, x2 minus x1. PQ minus 10 plus 6 all squared plus 20 plus 12 all squared. So Q is equal to, let's do it one shot, square root of minus 4 squared is 16 plus 32 squared. 4 root 65. That's PQ. Now we need QR. So QR is also equal to the square root of x minus x1 all squared plus y2 minus y1 all squared. So QR is equal to, we are about to do checkmate. We are about to do checkmate. So 14 squared, the square root of 14 squared. Who's the dummy? Maths is the dummy. Plus 14 squared. 14 squared plus 14 squared, which is equal to 14 root 2. Your answer is 14 root 2. 14 square root 2. Ha! We're about to checkmate him. Here comes the juicer. The juicer is our last formula. Bishop to e4. Checkmate. The kid drops. We're about to checkmate the square. Guys. Let's check. So here goes. So area is equal to half of PQ times QR times sine of angle beta. Do you remember this formula? Yes. Going to be doing it later on again. Onliners, how are we doing? Are you checkmating them? Are you checkmating them? Wish this live session was every month. Right, so let's go. Yes, 52,13, no problem. Angel, 52,1, we're keeping it, we just rounded it off to the nearest angle, 52 degrees. So area is equal to a half of what's PQ? 4 root 65. Yes. QR is what? 14 root 2. Side 52. Can you see how this board? And we are about to say checkmate. 4 square 65 multiplied by 14 square root 2 equals. I'm going to divide that by 2 equal. And I'm going to multiply that by sine 52. Boom! Moment of truth. 251,57, which is approximately, they say to the nearest whole number, 252 units squared. Some people, 252. Well done. Who was that? 251, Precious Mpila. Well done. Well done. Olwetu Shabangu. Well done. Something is wrong with your answer. You're getting 1,500. Clearly something is wrong. We were on our way to heaven. Somewhere along the line, you took a pit stop and went to hell. Beautiful. 252 units squared. Right. Let's take out one from a past paper now. And you're going to laugh at it because it's so easy. I mean, we did more difficult stuff today than what your past paper will give you. Right. Let's just have a look here. Let's have a look here. Here we go. Right. Are you ready to write the final exam component for 17 marks for analytics? Because we did more difficult stuff this morning. Onliners, are you ready? Checkmate Ntokozo. Checkmate. Right. Let's see if you guys can checkmate this one, guys. Here goes. Now, I think, or it's November 2022 Gauteng paper. So let's take this one down. Take it down with me. Don't worry which paper it's from. But now do you see the importance of first learning the art of doing something, then tackling your past papers? Some of you start with your past papers first. It's like the blind leading the blind. You will fail. Right, so they give you this. Take this one down. This is C. That's your y-axis. That's your x-axis. This is D, 0 and negative 10. D, 0 and negative 10. Guys, take it down with me. Is angle alpha, A, B. A, B, C, D. That's it. In the diagram, lines AC and BD intersect at B, which is perpendicular. The equation of AC, please read the question. They tell you AC's equation. AC is PY minus X. PY minus X. 5P equals 0. Equation of AC. Well, alpha is the angle of inclination, CDB. CDB is angle beta. There we go. Now this is last year's final exam. Let's go. I want the question number 1. They want the coordinates of C. So I'm not going to give you all the questions together. Let's all do the question for question. Now AC is given by that. So what I'm going to try and do is put it in the form y is equal to mx plus c. So I know py minus 5p is equal. So py is equal to x plus 5p. Y equals, so I'm going to divide by p. So it's x over p, or 1 over px, or x over p, plus 5p over p. That and that can cancel. Y equals 1 over px plus 5. Oh, in fact, that's my answer, guys, because I want the coordinates of C. C is my y-intercept. So basically, in fact, it's supposed to have been done here. You can do the answer here. This is your answer for question number 1. Y, I want the coordinates. That's 0 on my x, 5 on my y. Taken from there. Where? Taken from there. That's my y-intercept. Yes or no? We said py minus x equals 0. Py equals x plus 5p. Divide by p equals x over p, or 1 over px plus 5p over p to get rid of the p. So y equals x over p plus 5. That's my coordinates 0 and 5. Show all calculation. Wow. I know you guys are smart. I know you're going to get full marks here. Now look at the next question. Look at question number 2. Right, question number 2. If the gradient of AC, if the gradient of AC is, show that P equals 2. Show that P equals 2. What did we get the gradient here to be? Isn't it 1 over Px? I'm just going to rewrite it for you here. Just watch. Here's your answer. We got y equals 1 over px plus 5. That's your equation of AC. Do you all agree with me? It's what we just found. Now they're saying, so we know that the gradient of this line, so the m of this line is equal to 1 over p, which is equal to, and what are they telling us? It's 1 over 2. Yes or no? So if 1 over p equals to 1 over 2, therefore p is equal to 2. Finish. You've answered the question. Easy peasy lemon squeezy. Yes, Siabonga. They need to sleep here today so that they can get all the information. Beautiful. You guys want to sleep here? We work right through the night till tomorrow morning. Right, calculate the coordinates of B. Those of you who took this one down, start with the next one. They want coordinates of B. Question number 3. Want the coordinates of B. On down, you can start with number 3 already. So now we know the equation of this line. What is the equation of this line? So you must go back and put y equals, we found p, so it's 1 over 2x plus 5. Once you get an answer, to go onto your diagram and to put it back into it. Because you work with information on your diagram. You don't work with information from your calculation. Right, Sipo? Just want to introduce you guys to my friend Sipo here. Sipo, the year before last, he failed mathematics in grade 12. Last year, he attended the K-Way workshops. He got a distinction in mathematics. Today, he's one of the top tutors. He's doing engineering, chemical or mechanical engineering here at Mangasutu Buthelezi University, and he's tutoring the university in mathematics. So guys, I think let's give a nice round of applause to Sipo. And Sipo is here from KZN. We'll probably give Sipo an opportunity after break to just say a few words to everybody, a few words of encouragement. Sipo is a great inspiration to everybody here, especially not only in KZN, but a great inspiration to South Africa. Well done, Sipo. And watch the space. Soon Sipo is going to be taking my place. Right, here goes. Right, so we got the equation here, 1 over px. And they told us that the gradient of AC is a half. So 1 over p, here's it, the gradient. The gradient is a half. And we got the gradient from here, which is 1 over p. So if 1 over p is equal to 1 over 2, if I flip, so p over 1 is equal to 2. Therefore, p is equal to 2. That was for the previous question. The learner who asked me to please re-explain. Right, let's go. The coordinates of B, coordinates x and y. All right, we got the gradient of this line. We got the gradient of that line. We got the gradient of this line. The gradient of this line will equal to minus 2. Ah, beautiful. Beautiful question, guys. It's a beautiful question. It's a work of art. I want to see how clever are you. I'm just going to draw that line again. Just watch here. I'm drawing this line again. That's B. And that's D. This is D. 0 and minus 10. I'm just drawing that. That's 90 degrees. That's point B. And we got the equation of this line. Y is equal to a half x plus 5. Because it's 90 degrees, if this is a half, then the gradient of this line is equal to minus 2. Yes or no? Because that's a half, So the gradient, because the product of this must equal to -1. Right, now they want the coordinates of B. Right, do you guys want to see now a work of art? Onliners, how we doing? Where's our bra Khalid? DJ Khaled. Checkmate. Hungry like a lion. They're going to eat maths for dinner. Right, let's go. Shh, watch. If this value, if B's x value is x, what is y value? Isn't its y value a half x plus 5? Yes or no? If the x value is x, the y value at that point is a half x minus 5, because x and y. Y is a half x plus 5. So now all I do, I use the gradient formula, the m of BD is equal to y2 minus y1 over x2 minus x minus 2 is equal to y1, a half x plus 5 minus 10 plus 10 all over x2 minus x1. This is an equation. We now solve for x. Do it. I want to see that you know how to do your algebra. Shh. So here we go. y2 minus y1 over x2 minus x1 is equal to the gradient of BD. What a beautiful question. So minus 2 is equal to a half x plus 5 plus 10 plus 15 over x minus 0 is x. Shh. We are solving for x. It's an equation. Let's multiply by x. Let's multiply by x. What am I left with? Minus 2x is equal to a half x plus 15. Minus a half x is equal to 15. Minus 2 minus half, minus 2 and a half, which is minus 5 over 2. Minus 2 and a half, minus 5 over 2. So I'm just back up. So that is minus 5 over 2. X is equal to 15. Let's solve for x. Times 2 times 2. Minus 5x is equal to 15 times. Divide by minus 5, divide by minus 5. Here's your answer. X is equal to, positive divide by negative is a negative. 30 divided by 5 is how much? 6. So x is minus 6. Let's get the y value. Y equals a half x plus 5 equals a half into minus plus 5. This is equals 3 plus 5, 2. Your answer for B, the coordinates of B, minus 6 and 2. Line has got negative 6 and 2. Yes, Siabonga. Yes, Siabonga. Let's check. Yes, Precious. Negative 6 and 2. Sandiso, negative 6 and 2. Yo, Sandiso is on fire. Keto is on fire. Checkmate. Game over. Okay. Find me the area of OD. Let's call this point T. I want the area of ODT. I want you to work that one out. I want the area of ODT. Find me the area of ODT. I want the area of ODT. And this is an easy one, guys, because this is 90 degrees. So here we can use half base times perpendicular height. I only need to find my coordinates of t. Find me the area of ODT. Guys, you are amazing. I know. To work, you need to activate. You guys need to engage. You need to practice. Shh. So I want the area. This is the last question. The area of ODT. We've got a couple of questions. We've got two more questions and then we're going for break. It's already 10:15. So we're finishing this. We're going for break. We're coming back at from 10:30 to 11 is break. We're going to resume from break and we're cracking trigonometry, reduction, identities, general solution, triangles, non-90 degree triangles. That's going to take us right through until lunch. From after lunch, we'll do trig graphs and we'll do Euclidean. Right. The area of ODT is half base times perpendicular height. But we don't have t's coordinates. Can I find t's coordinates? Right, I need to find t's coordinates. So firstly, we need to find the equation of BD. In our answer, we need to find the equation of BD. So the equation is going to be y minus y1 equals m into x minus x. Use these coordinates. Y plus 10 is equal to m minus to x 0. So y plus 10 is equal to minus, that's x, minus 2x minus 10. Y equals minus 2x minus 10. Minus 2x and the value is given there already. So minus 2x minus 10. You didn't need to do this whole thing. If you wanted to, no problem. If you didn't show that and you just gave that, no problem. Because minus 2x and you given the y-intercept, minus 10. Right. So now for t's coordinates, your y value is 0. You need your x value. So minus 2x minus 10 is equal to 0. Because we don't have the y, is equal to y. We don't have the x. Minus 2x is equal to 10. X is equal to minus 5. These coordinates is minus 5 and 0. So therefore, area is equal to half base times perpendicular height. So area is equal to half of 10 times your perpendicular height, which we just found, 5. It can't be negative. Your distance can't be negative. So area is equal to 10 times 5 is 50 divided by 2 is 25 units square. So Right, last two questions before break. I want the value of alpha and prove that ABOD is cyclic. Your next question, find angle alpha and hence or otherwise that ABOD is cyclic. A little bit, guys, a little bit of Euclid here, not too much. To prove it to be cyclic, we need to prove either angles in the same segment or exterior angle equal to interior opposite. And I think that's the way we're going. I think we're going exterior angle equals interior opposite. Boys and girls, these are the last two questions before break. We all must say thank you to all of you and all our 9,000, 10,000 learners online and our 400 learners here on site. You guys have been amazing for the first session of today. You need to go home and you need to practice on all of this. When we come back from break, there's going to be fireworks. Trigonometry is fireworks. And I'm going straight into past papers word trigonometry. We're taking Gauteng's past paper, we're taking KZN, and we're taking Eastern Cape. So stay tuned to the entire program, guys. We've got lots of good stuff happening. Juicy food for you today in math. Let's answer this for break. It's 20 past already. Right, so here goes. Right, so tan alpha is equal to the M of line AC. Yes or no? I'm going to put a tick. Do you all understand that? Grade 11s, are you following? Right, so tan alpha is equal to the M of AC, so tan alpha is equal to how much? What's the gradient of this line? 1 over 2 or half. So alpha is equal to shift. Use the shift key on the calculator. Shift 10 half. 26,6. So alpha is 26,56, 26,6. And hence or otherwise prove that ABOD. Come on guys, watch here. Come and show you how easy this is. So ABOD, for it to be cyclic, we need to draw a circle around ABOD. Already see, I'm going to highlight this for you. If that is the circle, you can already see that, and that. So you can already see a bow tie. So if you see a bow tie, you already know angles in the same segment. They say hence or otherwise, any way you feel. So if this is 90, that is 90. These two angles are equal, angles in the same segment. So this is how we answer it. We say ABD, angle ABD equals 90. TOD, angle TOD equals 90 degrees given. ABOD is cyclic. Inverse of angles in the same segment. Angles in the same segment at RE. Therefore, ABOD is cyclic. And there we go, boys and girls. You're going to get how many marks? This was 17, and I asked you 2 extra questions. 25 marks. We just guaranteed ourselves for the exams. This brings us to the end of our session, first session. It's time for breakfast, our first comfort break for today. Onliners, thank you so much for being part of this program. We'll see you. We will resume at 11 o'clock with trigonometry. You don't want to miss the next session. Honestly, you don't want to miss the next session. I'll see you back in the session at 11 a.m. Onliners, enjoy your break. Yes, Andiso, converse of
So there we go. That was Mr. Khota. He just completed the first part of the grade 11 maths workshop, where he is focusing on maths paper 2. It is a revision of past examination papers in preparation for the examination. We host these sessions during the course of May, and this edition is the August edition, and we will be hosting another one in October. Please keep your comments going. We really love your interaction. We really have a bright cohort of learners that's in person with Mr. Khota. He's got about a cohort of 400 learners at the Al Falah College in KwaZulu-Natal. And we've got a very interactive cohort of learners that's logged on via Awqaf's YouTube platform. Please subscribe to our platform. We really like to reach that 7,000 subscriber mark before the end of the session. We will be speaking to a learner, a grade 11 learner from Soshanguve East School in Pretoria. And the learner's name is Michelle. And we really like to thank Mr. Clement. He's a maths teacher at Soshanguve. He comes on regular for our session. So let's bring on Michelle. And we also have Khalid. Khalid will also be taking you through the program. He will be facilitating the program, the back end that is up to lunchtime. So let's bring on Michelle, and Michelle's going to tell us more about how she is experiencing her session. Good day, Michelle. How are you doing? How's it going with the workshop on your side? Please let us know.
It is very good. Good morning. Happy Sunday. How are you?
I'm well. I'm fine. Thank you so much to Mr. Clement, your teacher, for facilitating the session. So tell me, what was the scene like yesterday? I believe that you had a group of learners together that was logged on to the Maths Paper 1 session. Please tell me how these sessions went yesterday and how is it helping you for your examination preparation?
The sessions were very well. Firstly, you packed everything, every topic beautifully, and you made it very easy. Like you made everything seem easier, and it was just good in general.
Okay, so
So
tell
yeah,
me, are you going to get 100% in mathematics for your final examination? What sort of
definitely.
expectation do you have for your examination, seeing that you're getting help from one of the best teachers in the country, and that is Mr. Clement?
So in my opinion, I feel like if we continue with these sessions, it will help us like be better in mathematics because they are very good and they are very entertaining and very like they bring lessons and they're very good. So if we continue with these lessons, I feel like we're going to get somewhere. We're going to get better in mathematics and understand mathematics better. So my goal for term 4, my final examination, is 90 and above, and I feel like we can achieve that if we continue with these lessons, because Mr. Khota is a very great teacher. I like yesterday I enjoyed his lessons. I enjoyed his study methods. His The way he does things is very easy, is very understandable, very entertaining, not boring. So like the way he explains things, he goes more into detail and you understand better as a learner.
No, that's fantastic. So we'll definitely pass that word on. I think Mr. Catherine is on the line, so you will probably pass on. We'll pass on that feedback from Mr. Kota. And tell us a little bit more about Mr. Clement, your maths teacher at Soshangove East High School in Pretoria. What sort of a role does he play in supporting you guys in your preparation for exams?
Mr. Clement is a very great teacher. Starting with, he's a very excellent teacher. Like since he taught me this year, I never understood maths before, but now I understand maths more. I feel like there is no need to like go to YouTube like I used to like yes last year. This year I understand things better. He makes maths fun. He always says that he's a smart teacher. He sends links, he sends everything like to help us achieve better in maths, to understand maths more. He's a great teacher in general. He's funny, he makes maths jokes, he understands maths. If you have a teacher and that teacher loves to teach, you will love to learn. You won't feel like you need extra help. He brings study guides, he brings maths in a fun context. He's like the best teacher. So even other schools know him because like the way he is great, they understand him better. you know he makes maths more easier, like more relaxing. You won't have stress when you're supposed to practice maths or something like that. You'll just feel like, okay, this one I went through it with Mr. Clement, and now it seems more understandable, more easier, because like he makes maths very easy. Like he's one of the best teachers I know there, and he needs appreciation, right? So now I feel like he deserves more right now. Like he's the best at his work. He loves his job. He loves maths, and then he makes topics more simple. That's all I can say about him.
No, fantastic. So I think Mr. Clement, Mr. Kota, and lots of other countless teachers across South Africa, they are the unsung heroes of this project. So, Michelle, we're going to be calling on you for our future programs. Good luck with your studies. Thank you so much for your time, for your
Thank you.
inspiring words, and your motivation. And just in conclusion, let us know what are your plans? You're going on to grade 12 next year. What is your future plans in terms of after school? Do you have ambitions to study at university? What does that plans look like?
So, firstly, I would like to go more into detail with my grade 12. So, I would like to achieve better results than I am achieving currently. I am a great student and I get good results in every subject. But next year, I just want to get more into school, like get all sevens, all 90% and more. So, I want to improve what I am right now, right? So that I can go to university. And then in university, I'm planning on studying actuarial science, because I feel like the way I love maths and physics, it's something that I'm passionate about and something that I can go through with, easily without feeling any pressure. Even if there is pressure, I'll work better under pressure. So if there is a chance that I can get into actuarial science, I would love that. And that's it. That is what I want to study, to go further with in university after matric.
Thank you. That's definitely encouraging. Looks like you've got some ambitions, some big plans beyond grade 12, and we will be in contact with you, tracking your progress. So, here's to your success. Thank you so much, Michelle. That's where we leave it off with Michelle. She's a learner from Sosengove East School, grade 11 learner, and she's definitely heading for the 100%. So she's definitely got some potential over there. So I'm just gonna try and see if we can play this video. There was a video captured by Zafir from Alfala School with Mr. Khota and some of the cohort of learners during the break time yesterday. So yes, so what Alfala does is they bus in learners from the surrounding schools to attend the session. Let's see if I can get this video. So there we go. That's the jovial scenes. They're coming to you live from Al Falah College for the Awqaf SA Grade 11 workshop. Assalamu alaikum, Khalid. Let us reflect on that very joyful video there with Mr. Khota and the cohort of learners. Please let us in. What were they singing about? It seemed like such a happy and a very happy vibe, and a vibe that's full of hope.
Yeah, Assalamu alaikum to you, Hasanain. I'm just enjoying, by just looking at the video because it brings memories, man. I was in KZN for plus minus 3 years, and that was just the mood, it said, because for Africans, as Africans, music is part of who we are. We've got that rhythm. So the one that they were singing there is called Alala. I think Alala is a very common term. You will know as well that it's sort of a song that will be sung, during marriages, during ritual ceremonies, whatsoever that is in a celebratory mood. Then they will sing that. You can just feel, the nature of the song. It caters for everyone. Everyone can just be part of it. So it doesn't matter from which race you come from which ethnicity or ethnic background you may be coming from, but you are able to feed from there. So that's why I was smiling all time, looking at them singing that, because for me, as much as the song will be sung in marriages, in all celebrating ceremonies, something like that, the fact that they are singing that song before a pure maths workshop, it means that Awqaf is stepping in the right direction, because you don't just sing that one because it reflects the mood of the whole people, who are singing it. So it's very, very encouraging, pleasing, and it brings joy to my face to see students singing such, we call it equijo, to singing equijo before a maths workshop, because That's the thing, or that's the mood you will only see maybe if you take students out for a sporting program. Maybe you've got athletics, then that's what they will sing.
So it's
But
all happy. It's all
it's all
happy.
happy. It's
Mood
all
is up.
happy. It reflects the mood, and that's what we want to see at Awqaf as well, because we don't want sessions that are boring, which is why we've got Mr. Khota, and you can hear the students. I mean, every time they mention Mr. Khota, he's got a certain way of teaching mathematics. So it is pretty much encouraging.
No, fantastic. I love the spirit in which, our African people express happiness and joy. You don't need to understand the lyrics
Yeah.
or you've given us the context, but you can kind of feel that, that it's comes from a place of hope and appreciation and joy and that expression. So tell me, how's it been going with the maths workshop? You were on the session yesterday for grade 11 maths paper 1, maths paper 2. How's it been going? You've been quite key as part of the program, handling some of the admin and some of the continuity presenting.
If there is something I can mention to you, Hasanain, about the workshop, is that everyone who is here is kind of relaxed, because I do manage the comments and read all the comments from the students, those who will be typing in isiXhosa, in Zulu, in whatsoever language they will be typing in. And they give me a sense of people who are comfortable on this stream, because sometimes you get into a place and then you are like, do I even belong here? But what we have been able to do as Awqaf SA is to sort of give them a facilitator like Mr. Khota, who will make you comfortable. Because if you listen to some of the students we interviewed yesterday, when we spoke to them, asking them as to how the workshop has been helping them and so on. They were saying that some of them that in January they failed their March examination, which was the first term. They failed their first term, and then they were introduced to this platform, and then they went on to pass with plus minus 75%, of which they also made mention that it's not their potential. They can go on to get distinctions, and they hope to stay on this platform and to get distinctions. So it's a message of hope. Last week, we made mention that South Africa is ranked lowest when it comes to maths and physics. And I think this is a step in the right direction, because associated with mathematics and physics, in the past, it was there was a perception that this thing is rocket science. Now we want to see students who will sing like those students who are singing before doing mathematics. It's a message of hope. It's a message of we are getting where we want to be. I know we are far away from where we want to be, but in order to be where we want to be, obviously necessary steps have to be taken. So managing the stream and checking the comments, I think we are on the positive direction.
There we go. That's where I leave it, and I hand it over to my co-pilot Khalid, and he'll be taking you through the session. Khalid, it's over to you. I'll be seeing you later.
And that was Mr. Hasanain Abdullah, of course, the project manager of Awqaf SA. In case you're wondering as to where is the maths teacher, or you've just joined us, someone told you that there is a platform like this and you are seeing us talking to each other here, there is no maths workshop or something like that, it is still a commercial break. So to boost your math skills and excel in your exams, you need to join us for a comprehensive workshop that is hosted by Awqaf SA in association with the Department of Basic Education, Thread Waqaf, iSkill, and Al-Falah College. Al-Falah College, which is situated in Durban in South Africa, KwaZulu-Natal province. It is still a commercial break, of course, and that's where I will leave you for now. As soon as Mr. Khota comes back at 11 o'clock, We hope to see you. We hope to get you refreshed. We hope to get you ready. And all those students who are mentioning, during the sessions that they are hungry, this is your time to eat. Because if you don't eat now, you'll have to eat maths at 11 o'clock.
minute. Welcome back, welcome back, welcome back. We are in round 2 out of 3 rounds. Welcome our onliners. Thank you for all your comments. Loving your comments. Nice to see everybody all engaged in our program. Guys, lots of fun for today. We're starting with trigonometry. For those of you that have just joined us, we started with analytics this morning. We are now getting into trigonometry. So, Sidelile High School, thank you for the revision. Watching from Sidelile High School, Magabeni Township, KZN Province. Welcome to our program. Thank you for joining. Keep the comments coming in, guys. We'd love to communicate with you. You want to send a shout out to your school or to your friends or to your learners. Let us know your comments. Hit us up in the comment section and let's all work together to improve mathematics. Guys, we are back in session. Thank you very much. We are back in Tokozo, promise. Well done. We are starting with trigonometry. Take a deep breath. Get your waters, get your hydration, get your scientific calculators. I am going straight into past papers. Guys, we're going to be working through 2 past papers. Let's get cracking. Let's get started. Welcome everybody. Welcome back. Let's get fired up. So here we go. The first question in trigonometry. If 3 sine beta equals 2, so now in trigonometry, what do you need to know? Trigo with the aid of to sketch a diagram. Number 2, you need to know reduction. Identities where we prove left hand side equal to right side. To know trig equations and general solution. Number 5, we need to know 90-degree triangles. The air rule, the sine rule, the cos rule, trigs. Gotta check how much. This was 27. About 40 marks, plus minus 40 marks for trigonometry. So 35 to 40 marks on your analytics. 40 marks on trigonometry, that gives you 80. 20 marks on your stats or data handling, that gives you 100. And about 50 marks on your Euclidean, that would give you your 150 marks for your final exam. So boys and girls, take your seats, take a deep breath, let's get started. The first question, where they ask you with a diagram, with the aid of a diagram, if 3 sine beta equals 2, if 3 sine beta equals 2, and cos beta is less than 0. Find with the aid of a diagram. Find with the aid of a diagram. 3 cos squared beta minus 1. Number 2, 10 minus beta minus 180. Number 3. No, it's only these 2 questions. Okay, so great. Have a look at this. This is your opening question in your final national or provincial exam paper. Let's crack this question. Let's check our onliners. How's our onliners doing? Are we back their mission? You still didn't eat. Why not? You had 35 minutes. Shout out to Mrs. Mutala from Orient Islamic School, from Ghulam Abdul. Mission, you better eat, brah. You can eat while you work. Nobody says you can't eat and work at the same time. We're pushing through till 12:30. We got 1.5 hours to do trigonometry. You're going to enjoy the session. That is something I promise you. Let's build our chessboard. Let's put our pawns in action. The first thing that we need to do, pay attention in our answer. Step number 1, put this in standard form. Now wait, pay attention here, guys. The method that we use is scrap. Do you guys remember this? Do you remember if you've been part of our previous workshops? Okay, what is S? This is step number 1, step number 2, 3, 4, 5. A is just for and. Step number 1, put it in standard form and use Sokato. C, Cartesian plane. Look at your restriction to see which quadrant to do. And P is just for and. P is for Pythagoras to complete. So guys, if you use this acronym for drawing diagrams, you'll never go wrong. Standard form, Sokato, Cartesian plane, and Pythagoras. So let's scrap this, guys, back and stronger. Michelle Ramutla, yes. Sine beta is 2/3. Very good. So let's put it in standard form. Let's go. Right, so in our answer, sine beta is equal to 2/3. Sokato is over hypotenuse. Cartesian plane. Let's draw our Cartesian plane. So I'm just going to erase all this here on the side. Cartesian plane. I'm drawing it here on the side. There we go. So I've done I did standard form and Sokato. I drew my Cartesian plane. Let's look at restriction. Sine, where is sine positive? Sine is positive in my first quadrant and second quadrant. Remember ASTC. Thank you, grade 11s. Right. ASTC. Sine is positive in my first and second quadrant. But where is cos less than 0? Where is cos negative? In these two quadrants, where is cos negative? In my second quadrant. So wherever you got 2 ticks, because you're fulfilling both these conditions, you're fulfilling where sine is positive and where cos is negative. That's the Cartesian plane. That is the quadrant in which we draw our triangle. Beta is there. Sine is opposite over hypotenuse, so that's 2/3. And we need x. So obviously we use Pythagoras. That's why we have P. We use Pythagoras to complete our diagram. Right, so 3 squared is equal to x squared plus 2 squared. This is Pythagoras. 9 equals x squared plus 4. X squared equals 9. 4 is 5. X is equal to plus or minus square root. So it's negative the square root of 5. Please, guys, put in the negative. You're going to get everything wrong after this. So let's check our onliners. How are we doing there? Everybody getting it right? Let's check. People have already drawn the triangle and people are already answering. So let's go. So let's now answer. You have to draw this first. Now you start answer. So here's your answers. The answer to question 3 cos squared beta minus 1, which is 3. Write it like this. Cos squared minus 1. 3. Cos, according to adjacent to Sohcahtoa, is adjacent over hypotenuse minus root 5 over 3 square 1. Now we can use our calculator. 3 open brackets fraction minus root 5 over 3 close bracket squared minus 1. Your first answer is 2 over 3. Let's see who got that right. Onliners, Siabonga, Mashaba, 2 over 3, well done. Angel, 2 over 3, well done. Michelle Ramutla, well done. Beautiful. Beautiful. Now answer the next question. The next question tests our negative angles. Be careful. Be careful with that one. Let's answer question number 2. I'm just answering question number 2. 10 of beta minus 180. Watch what happened. So let's erase that. That was Pythagoras. We don't need that in our problem. That's sorted out. Right. Let's clear the frame a little bit. Let's clean it up. Let's clean it up. Question number 1. Watch what we do with question number 2. This is equal. Please be careful. Take out the negative in the brackets. Minus into. Now change these two signs. Beta plus 180. Watch this, please. This is important. I'm writing it here. Important. If they had to ask you cos minus beta minus 180, I'll show you how to do the cos one. So tan of an angle, so you can write it like this, tan beta into minus around 180 plus beta. Now, this is a negative angle. Tan of a negative angle is minus tan. Beta tan into, right. Tan. You took out the negative sign. Tan of a negative angle is minus tan 180 plus beta. So now, tan 180, the name stays the same. We're doing a reduction. Tan 180 plus 180, that's 180. 180 plus is in my third quadrant. Tan in my third quadrant is positive. A positive times a negative is a negative. That's minus. Tan is opposite over adjacent. 2 over minus root 5. Your final answer. Your final answer coming up. This is equal to negative times negative is a positive. Your answer is 2 over square root 5. We go. But what if they asked you cos of minus into beta minus 180. Let's see you do that on your own. Do that part on your own. It's done very similar. Onliners, let's see who got that one right. 2 over root 5. 2 over square root 5. Well done. Well done. Luyanda, all we're doing is we're going through that, we're using the diagram to answer our questions. Right. We convert this to a negative angle, so it's minus into beta plus 180. Tan of a negative angle is minus tan of the angle. And we all know how to reduce, guys. This is basic stuff. This is grade 10 work to reduce. Let's do the next one. Who's done with number? Right. So that's cos minus into. Right, now wait. Watch here, watch here, watch here, watch here, watch here. What is cos of a negative angle? Cos of a negative angle, listen to me carefully. Cos of a negative angle of beta minus 180. Now you need to pay attention here. So this is again cos of a negative. Just to write it out for you. Sine of a negative angle is minus sine of that angle. Angle is minus tan of the angle. But negative angle is positive cos of that angle. The negative falls away. You need to remember this. Important. This is to do with your negative angles. Tan of a negative minus tan. Cos of a negative is positive cos of angle. Now let's go back. Now wait, watch here. So this would be cos minus 180 plus beta. I swap the two around. I make it a negative angle again inside. Cos minus into 180 minus beta. Now cos of a negative angle is positive, so that will fall away. The minus will fall away. So we left with cos 180 minus beta. Wait, we are busy. We are about a step away from reducing. So we got cos 180 minus beta. There we go. I just moved up there. The name stays the same, cos beta. 180 minus falls away. 180 minus is in my second quadrant. What is cos in my second quadrant? Negative. That's minus. Now cos is adjacent over hypotenuse. Answer is root 5 over 3. Final answer. Yes. There's a reason why I did this one for you, to show you the difference between the tan and the cos. Cos of a negative angle is always positive. Right, here we go. Next one. If t cos 15 equals 4, here comes the next one. I'm sure you all took this one. I'm just erasing the diagram. Question number 2. If t cos 15 equals 4, find the following in terms of t. Find the following in terms of t. Number 1, sine 15. Again, we have to draw a triangle, guys. We have to use scrap again, without the use of a calculator. Sine 75. Remember, all of them, they want them in terms of t. 1 minus tan squared 15. 1 minus tan squared 15. And they want you okay, mark elements 3, 2 marks, 3 marks. Marks, 2 marks, 3 marks. 8 marks on this question. Again, you have to draw scrap. You have to do scrap. The minute you see this, you got to draw a diagram. So standard form, Sohcahtoa, Cartesian plane, restriction, and Pythagoras. Let's see you do this one. Try it. Onliners, give this one a go. This is exact. Come onliners, well done, well done, well done. Once you've dealt with the outer negative, can we just add 360? Yes, you can. No problem, Angel. Well done, Michelle. Well done, Chepo. Well done, Olwetu and Angel. Oh, Siabonga is on fire. Square root t squared minus 6. I don't know the answers. I got no memo. We're all doing it together. I'll compare my answer to your answer. I'm sure you're right. I got a good feeling about you, Siabonga. Siabonga is sharp. Welcome, Siabonga. Right, let's go. All right, so let's go. Let's do exactly what we did. So t cos 15 is equal to 4. Cos 15 is equal to 4. This is adjacent over hypotenuse. No restriction is given, so I can draw it in my first quadrant. Because it's positive, everything's positive. My Cartesian plane, 15 degrees is my reference angle. Cos is adjacent over hypotenuse, 4 over t, 4 over t. I want this value. I can call it x or I can call it y. Doesn't make a difference. I'll just call it y. Vertical line we call y, horizontal line we call x. So I need y. Pythagoras, remember I'm using scrap. Pythagoras, let's do Pythag. Guys, before we answer the questions, let's do Pythagoras. T squared is equal to y squared plus 4 squared. T squared minus 16 equals y squared. equal to the square root of t squared minus 16. So that is the square root of t squared minus 16. Right, now we answer our questions. Here's our answers. Answer to question number 1, 15. Hypotenuse. Opposite square root of t squared minus 16 over t. Let's check. I think Siabonga was right. Didn't I tell you Siabonga is the main brain for today? Siabonga, or let's see, what was Siabonga's first answer? Square root t squared minus 16 over t. Yay, Siabonga. Well done. Siabonga is who's Siabonga? Is he? You are lying. Your name is not Siabonga. It's not you. You are not the onliner. Yeah, your name is Siabonga. It's not you, this one. Well done, Sia. Well done, well done, well done. Number 2, sine 75, we have to reduce, is equal to sine 90 minus 15. Sine, remember 90 to 70 changes the name, sine to cos and cos to sine. So cos 15 is adjacent over hypotenuse. Your answer is 4 over t. Yeah. 4 over t, Siabong. Hey, Mashaba is on fire. Wasla niya. Right. Well done, well done, well done. We don't have a restriction. Is it in quadrant 1 or 4? Quadrant 1. If you don't have a restriction, quadrant 1, Angel, always draw it in quadrant 1 if it's no restriction given and it's positive. Quadrant 1. Good question. No restriction was given. So we just draw it in quadrant number 1. Our triangle is drawn in quadrant number 1 because no restriction was given. Right, let's answer question number 3. 1 minus 10 squared 15. You still writing? Right. Okay, let's answer question number 3. Shaba is going to be hitting 100% in mathematics. This 1 minus 10 squared 15. This is equal to 1 minus 10 15 squared. 1 minus. What is 10 15? What is 10 15? A Katoa. Opposite or adjacent. The root of t squared minus 16 over 4 squared. They want you as a single fraction. So 1 minus square and square root will cancel. We left with t squared minus 16 over 4 squared is 16. Shh. They want it as a single fraction. So they're testing you, your algebra. Do you know how to add algebraic fractions? So let's do that. This is equal to 1 over 1 minus t squared minus 16 over 16. My common denominator is 16. LCD. 1 into 16, 16. 16 times 1 is 16. Minus 16 and 16 will cancel. Please be careful. T squared minus 16 in brackets because of the minus sign. 16 minus t squared plus 16 over 16. You're going to be left with 16 plus 16 is 32 minus t squared. 32 minus t squared over 16. And there we go, that's your single fraction. Final answer. Checkmate. Let's see who got that one. The last one. Why do we reduce on number 2? Number 2 you have to reduce because your reference angle was 15 degrees. So, okay. I just want to go back to this one here where they asked us about sine 75. Remember what our diagram looked like. Again, guys, we had our triangle, we had 15 and 15, cos 15 was 4 over t, and what was this? The square root of t squared minus 16. Now, just to show you, go back to number 2. I think I know why they're asking. Did we have to reduce? You see, if that is 15, this is 75. Because 15 plus 75 is 90, 90 plus 90 is 180. So if you want sine 75, therefore sine, I'm answering question number 2. Therefore sine 75 can also be opposite over hypotenuse, 4 over t. So you could have done it, these are right. I think that answers the question. Yes, Yafro Furi, Mashaba is a goat. He's a G in math. Lovely. Mashaba is on fire. Right. There we go. We're done with this one. I'm taking out another one. Mashaba is slaying math today. Right. A 6-mark question in terms of reduction. So come, let me clear the frame. We are into final exams. Right. Simplify. Ashaba, 90 minus alpha. Let this one, cos 90 minus alpha, sine times sine, minus alpha minus 540, all over 10225, plus sine alpha times sine 180 plus alpha. For 6 marks, simplify. So guys, be like Mashaba. Mashaba, you the main brain for today, Mashaba. Be like Mashaba. What was that guy, that main guy in the army that they always made fun of in South Africa? What was his name? The guy in the military, man. The guy who on social media who always messes up. He's in the army and then they say, no, man. What's his name?
Mabena.
Mabena. You know Mabena. You don't know Mabena. Mabena can't. He's in the army, in the military. They tell him to climb a wall. He can't. Don't be like Mabena. Please don't be like Mabena. Be like Mashaba. Otherwise you're going to be like Mabena trying to climb the wall in trigonometry. You're just going to fall, capsize all the time. Why are co-functions called co-functions? Sipalele, co-functions are called co-functions because... do you mean co-functions or co-fusions? Yes, you'll end up going off on a tangent, Yafro. Tell them, I need Yafro Furi next to me here. Yafro Furi, at our next workshop, you are joining us on stage. Asanda Mvubu is hungry. Yeah, these people are just hungry. All the time they are just hungry. All right, let's do this. This is reduction. Let's do it together. Mabena, you done? Mashaba, you done? The minute you are done, just type in there, done. Type in done. You don't have to give me the whole answer. Sipelele, co-functions are called co-functions because the name changes from sine to cos and cos to sine. When you're reducing 90 and 270, the name changes to its co-function. Okay, Mr. Gendry is done. Well done. Well done. Done. Mashaba, let's go. Cos 90, because it's 90, it changes to sine alpha. Times sine. Again, your negative angle, minus into. Now, I'm changing both the signs. Alpha plus 540. Be careful there. All over. 10 225 is 10. 180 plus 45. Your special angle. Plus sine alpha. Sine 180 and 60 name stays. Sine alpha, but be careful. 80 plus is in my third quadrant. Sine in my third quadrant is negative. Negative times a positive makes it a negative. Again, I'm telling you guys, I don't have a memo in front of me. We are doing it together, step by step, like how you would answer it, or how you should answer it in your exam. Now let's get rid of this. Let's do it together. Sine alpha times sine of a negative angle is minus sine. I'm just going to flip these two around. 540 plus alpha all. And 180 will stay 1045. 180 plus is in my third quadrant, is positive here. Minus sine times sine is sine squared alpha. Ha! We're getting there. We're getting there. We're building our chessboard. Sine, we're developing it. Sine alpha times. Don't forget, it's multiplied. It's multiplied. Shh. Now 540, you minus 360 from it. Any angle greater than, because the circle is only 360 degrees. 540 means it went around 360, you back to the start. So 540 minus 360 is the same as saying 180 plus alpha. So this is minus sine 180 plus alpha. Right, sine 180 will still remain sine alpha. 180 plus is in my third quadrant. Sine is negative, and negative times that negative is what? A positive. So the negatives are gone. Divided by tan 45 is 1 minus sine squared alpha. So sine times sine is what? Sine squared alpha over 1 minus sine squared. This is your I. 1 minus sine squared is what? Cos squared alpha. What is sine squared over cos squared? Tan squared. Not 1. Tan squared alpha. Mashaba. Mashaba had an answer of 1. Hey, Mashaba. Me make a mistake. I'm joking. Let's check. Where did I make a mistake in my second step? Show me. Cos 90 is sine alpha times sine minus into alpha plus 540. That's correct. Tan 180 plus 45 is correct. Sine alpha is correct. Sine 180 is sine alpha. 180 plus is negative. Negative times the negative. Yeah, it's right. Because, wait, let me just double check here. I'm going again. We got 10. That's it. Okay, let's just do this again. Let's do this part. Plus sine alpha multiplied by sine. That becomes minus sine alpha. That's correct. Positive times a negative is a negative. That's correct. That's correct. That step is right. Sine alpha times sine of a negative minus sine 540 plus alpha. That's correct. Over 10, 45. That's correct. Minus sine squared. That's correct. 540 minus 360 is 180. That's correct. 180 plus alpha. 180 plus is there. Negative. Negative times that negative is a positive. Hey, brah, I'm right. I'm right. I'm right. Which sign? Which sign? I'm correct. Thank you, Siabonga. I don't think I'm right in Kosimandla. I know I'm right. Thank you, Tsechofatso. Go fly a kite on a rhombus. Thank you, Yafro Furi. Yafro Furi got jokes today. She had a comic show for breakfast this morning. Thank you, Yafro Furi. We are right. We are right, Baba. We are right. We are. Let's go to the next one. Okay, let me give you some more. Let me go to another past paper here. Right, I'm giving you an Okay, I'm going to give you one more reduction to do. Easy. This was a bit of a heavy reduction, but it wasn't difficult. Let's give you another reduction. One more reduction. Then we're going to give you an identity to prove. Reduction. Tan 180 minus times cos 360 plus x over 2 cos 90 plus x. Is easy peasy. Come on, grade 11s, get this one right. Straightforward. Reduction for identity. I'll do general solution. It's already 10 to 12, quarter to 12. 12:30 we're going for lunch. And then I want to do trigs on different planes. Right, come, let's do this one. Tan 180 will remain tan x. 180 minus is in my second quadrant, tan is negative. Cos 360 will remain cos x. 360 plus is in my first quadrant, cos is positive. Over 2. Cos 90 will change to sin x. 90 plus is in my second quadrant. Cos in my second quadrant is negative. Please guys, don't look at the changed one, look at the original. Cos in my second quadrant is. Now negative and negative will cancel out. Tan x is sin x over cos x. Cos x over 1 divided by sin x. Cos x will cancel out. Sin x and sin x will cancel out. What is my final answer? 1 over 2. Easy peasy. One over two. Michelle, well done. Olwetu, well done. Michelle and Olwetu also on fire. Mary Z on fire. Well done, guys. Siabonga, you saw. Did you see where you made your mistakes, Mashaba? Where in the previous one where you got 1, now you got a half. Oh, you want a challenge? All right, somebody asked for a challenge. I love those questions. Sir, give us a challenge. All right, let's give you an identity. Let's give you an identity. So prove. Take this one down. Prove. Minus 2 sine theta cos theta all over 2 squared theta plus cos theta minus 1 equals minus sine theta over cos theta plus 1. Right, those of you who are done with this one on the left, start with the one on the right. Here's an identity because it's asking you to prove. Let's see if I can. Right, so I've got other identities as well. Theta plus 1 over 1 minus sine theta is equal to 2 cos squared theta. 2 for you to do. Okay. Who's done with the first one? One learner, you are lying. Only Mashaba and always too. Let's see if you guys done. Onliners, Yafro Furi, done. Well done, Yafro. Siabonga Mashaba, done. Well done. Well done, well done, well done, well done. Do you think you're right or you know you're right? Yafro, Siabonga, Mashaba, you think you're right or you know you're right? Well done, Angel. You know you're right. Bombi Shabalala, Mary Z, well done, Angel. Chiamo. Nokubongwa, Lukele. Amazing. Right, let's do the first one. The minute you see this, you see that and you see two terms, something is common. So we're going to go on the left-hand side. Common factor, sine theta. 1 minus 2 cos all over the quadratic equation. So break that up. So that's going to be 2 cos, right. So now we're going to have 2 cos, so we're going to have cos theta, 2 and 1. Your factors of 2 is 2 and 1. Your factors of 1 is only 1 and 1. You need plus cos theta, so plus 2 minus there. So this is equal to, you factorize that, that's a normal quadratic equation, 2x squared plus x minus 1. Now we need 1 minus 2, so I'm going to take out the negative here, so sine theta into 1 minus 2 cos theta all over, I'm going to take out the minus into 1 minus 2 cos theta into plus 1. Now, that and that will cancel out. Positive divide by negative, you're left with minus sine theta over cos theta plus 1 equal to your right-hand side. Left-hand side equal to right-hand side. Did you guys get this one right? Learn. Onliners. Michelle Ramutla, done with number 2. Olwetu done. Precious done. Chepo done. Let's do the next one. Left-hand side. We are adding 2 fractions. I'm going to do lowest common denominator because we're adding 2 fractions. So my common denominator is 1 plus sine theta into 1 minus sine theta. Cancel, I'm left with 1 minus. 1 minus sine times 1 is 1 minus sine theta plus 1 minus will cancel, I'm left with 1 plus. 1 plus times 1 is 1 plus sine theta. Theta plus sine theta, 0. 1 plus 1 is 2. There's the 2. Over difference of 2 squares. 1 times 1 is 1. Positive times negative is negative. Sine times sine is sine squared theta. Your identity, 1 minus sine squared, is what? Cos squared theta, which is equal to your right hand. Right, now the next question is worth 7 marks. They give you a bit of an identity and then they give you general solution. It goes into general solution. I hope you all got that one right. Let's go. Right, here goes the next one, guys. I'm clearing the frame. You guys are too slow. All right, let's do that already. They give you this. 1 minus cos theta is equal to 2 sine squared theta. Right, question number 1. Show that the equation can be written as, show that the above equation can be written as 2 cos theta plus 1 cos theta minus 1 equals 0. Number 2, hence determine the general solution Question 2 marks, 5 marks. Total marks 7. Yeah?
Another one, give them central.
Yeah, wait, through the. Yeah? For these ones?
Yeah, the one who got the answer first, give them central, another one central.
Lovely, 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 lovely. So for a couple of the questions, Sipo has come up here. Sipo says, we're going to have a little competition here in-house. So when we do a couple of questions, 2 prize monies, 20 rand for getting certain questions right. So let's see. Let's see. All right, not for this one. I'll give you questions to do for money. Thanks, Sipo. Sipo is generous today, guys. Okay. Mashaba must be done. Mashaba must be done. This is baby work. Done with number 1. Done with number 1. So 1 minus cos theta is equal to 2 side minus 2 sine squared theta minus cos theta 1 equals 0. Cos. So minus 2 into sine squared theta is 1 minus cos squared theta. Theta plus 1 equals 0. Multiply this out, minus 2 plus 2 cos squared theta minus cos theta plus squared theta minus cos theta minus 2 plus 1, minus 1 equals 0. Break that up equal to 0. You'll get 2 cos theta plus 1 into cos theta minus 1. And there we go. That's exactly what we... I'm sure you all got that one right, onliners. I'm sure you all got that one right, yes. Oh, onliners also have PayPal. Beautiful. Beautiful. Baby work. And this is from a past paper. Hence, determine the general solution. Now solve for theta. Let's answer question number. I hope you took this down. Right, so we're answering question number 2. 2 cos theta plus 1 into cos theta minus 1 equals 0 to give the general solution. And now here we need to solve for theta and give the general solution. You got 2, so 2 cos theta plus 1 equals 0 or cos 1 equals 0. You split it up, you give 2 general solutions. Let's go. 2 cos theta equals minus 1. Cos theta equals minus 1 over 2. Theta is equal to, shift cos minus a half. Shift cos minus 0,5, 120 degrees, plus minus 100. You must put a plus minus. 120 degrees plus k times 360, where k element of integers. Why plus minus for cos? Because cos appears there and cos appears there. Plus minus. That's why we put plus minus. Or cos theta equals 1, theta 1, 0 degrees plus k times 360, where k integers. That's your 2 general solutions. Remember sine and cos, your general solution is k times 360. Your tan is plus k times 180. Okay. They don't give you a restriction. You can leave your answer just as that, or theta can equal to shift cos 1 is 0 degrees or 3. I just want to see cos 0 or cos 180. Cos 180 is minus 1. Cos 360. Or theta is just equal to 360 degrees plus k times 360. Okay. But you get like this, because if you put in 0 or 1 year, you're still going to get 360 degrees. Let's give you another 1 year. Let's give you 1 year. Let's give you one in terms of tan. If I told you, let's make an up, let's say 2, 10, 2x plus 10 degrees over 5 minus 8 equals 0. Solve for x. Give the general solution. Give the general solution for 5 marks. Right. Go for it. Try this one out. Then I'll give you one. We'll end up with one in terms of sign. In fact, we'll do 2 more. We'll do one in terms of sign, and then we'll do another one where you've got to use highest common factor. We're moving on fantastic time, guys. Let's do this one together. Let's put it into standard form. 210 2x plus 10 over 5 is equal to 8. 210 2x plus 10 over 5 is equal to 8 over 2, which is 4. 8 divided by 2 is 4. 8 over 2 gives me 4. Shift tan 4, so your reference angle is 2x plus 10 over 5 is equal to, shift tan 4, I think it's 75,96, which is approximately 76. Let's check. Shift tan 4, 75,96. So let's say 76 degrees plus k times 180 or 180k, where k is for x, times 5 times 5. 2x plus 10 is equal to 76 times 5, 380 degrees, plus k times 180 times 900, where k is an element of integers. Take 10 on is equal to 280 minus 10, 380 minus 10 is 370, plus k times 900, where k is integers. So x will equal to 360 divided by 2. 185. X is equal to 185 degrees. Plus k times, we divide by 2, 450. Where k is an element of integers. Your general solution for this one. That is your general, yeah boy, yes. 185 plus k times 180. Come guys, we are just solving an equation here. We are just solving an equation. I might be doing shift tan 8, shift tan 4 is 75,96. There's your reference angle. And for tan, your general solution is k times 180. All I'm doing is solving for x here. Times 5 times 5 times 5. We're solving for x. That's all we're doing. We're solving for x. Okay. Let's look at another one. Give me the general solution. I'm going to give you this. I'm going to give you another one too. And I'm going to give you one more. I'm going to give you 3 to do. They each worth 5 marks. All right, give me the general solution for each of these. 5, 10, 15. 15 marks here, guys. 3 general solutions to do. And that should take us almost till, or in fact, will take us till lunch. It's already 12:15. Crack these 3. Shh. They all done quite differently. That's why I'm giving you, these are 3 different styles. Style 1, style 2, style 3. Know all 3. Know all 3. "17 minutes till break, Yafro." Let's crack this. We are working exactly according to time. Let's go. Oh, Siabonga is done with number 1, I think. I don't know what the answers are. I just made them up. So I'll work them out when we do it together. What's important is not the values. What's important is the pattern, the style in which the question is asked, and how to unpack it. The values will always change. Right, let's see, Mashaba. Mashaba, you got the first answer. 2 sine 2 theta minus 20. Mashaba got the answer for the first one. 2 sine 2 theta minus 20 degrees minus root 3 is equal to 0. Shh. Let's see if Mashaba is right. So 2 sine 2 theta minus 20 is equal to divide by 2 divide by 2. Sine 2 theta minus 20 is just putting it into standard form. If this is too fast for you, you are never finishing your paper. You're going to be in big trouble. You know who you're going to look like? The break dancer in the Olympics. You know the break dancer? They don't know the break dancer, Yafro. The break dancer in 2024 Olympics. They're going to end up looking like that in their paper. Fatima Peters, Yanga, Ngubo. Ngubo. Right. Shh. So now, pay attention. Now you split it up. You got your answer for quadrant 1 and you need an answer for quadrant 2. Quadrant 1, 2 theta minus 20 is equal to shift side 60 degrees plus k times 360, where k is an L plus 20 is 80. Plus k times 360, where theta is equal to 80 divided by 2 is 40 degrees. K times 360 divided by 2 is 180. That's your first solution. Let's see who got the first solution right. Not 40 plus k times 90. Yes. All the Korean cheerleaders. Same one, ma'am. Same one. That break dancer. They're going to be break dancing in this exam. Right. Shh. So there we go. That's your first solution. Or quadrant 2. 2 theta minus 20 is equal to 180 minus quadrant 2 is 180 plus k times 360, where k is an element of 2 theta will equal 180 minus 20 plus 20 is 140 plus k times 360, where k is an theta is equal to 140 divided by 2 is plus k times 360 divided by 80, where k is an element of integers. These are your two general solutions. You will get 5 marks for this. Learn this. We got 2 more to do before break. Going for 20 past 12. We got the last. It will take us a couple of minutes. We should finish it off by 12:30 on the dot. Be careful with the next 2. I'm sure you all got onliners. 70 plus k times 180, nokubongwa. You had to divide the 360 also by 2. You had to divide the 360 nokubongwa also by 2. Don't forget, when you're multiplying or dividing, it affects your general solution. If you're adding or subtracting, it doesn't. Okay, thumbs up. Double dolly, June, July. Angel, you are smart. Siabonga, which one is it? 36,87. Was that the next one? I don't know. I don't know where's the 36,87. Mashaba, what you are talking about here, Baba? For which one is that? 36, what are you talking about, Mashaba? You are smart. You just need to practice. Right. You all took this one down? Start with the next one. Or maybe Mashaba answered the last one. I'm not sure. Mashaba, I don't know what the answers are. I got no idea what the answers are. We're working it. Yes, I assumed. Okay, Mashaba, we'll see if it's 36. I'm sure you are right. But the last one got 2 solutions also. Mashaba, the third question got 2 answers, Baba. Got 2 solutions. That may be 1. You short of 1 more. Okay. We're almost there. Let's go. Sin x is equal to sin x cos x. by sine. Do not divide by sine x. You will get the whole problem wrong. You never get rid of a trig function. Many of you, you say, oh, so easy. Divide by sine, divide by sine. That and that, that and that. Cos x equal 1. Wrong, 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 wrong. Some of you are smiling because that's exactly what you did. You divided by sine. I know it's very tempting, sin x to sin x cos x. Shh. What you do, you take this on the other, you got sin x minus sin x cos x equals common into 1 minus cos x equals 0. So I'm not getting rid of. Now I got two general solutions. Sin x equals 0 or 1 minus cos x equals 0. X 0 degrees plus k times 360, where k is an element of integers, or x is equal to 180 plus k times 360, or on this side, minus cos x will equal to minus 1. That cancels out. X is equal to what? Shift cos 1. Zero degrees on this side also. You must solutions in terms of sine and cos. But what if they told you, look here, okay, we'll do the last one. We'll do, yes, 5 minutes left, ma'am. Juffrou Fourie, 5 minutes left. Here we go. Let's do the last one. Last one. So let's see. Huh? You, okay, lovely. How many of you got the last one right? How many of you are done with the last one? So Sipo says we should give 50 rand to the person here, 50 rand for the person who comes up and gives me the last one correct. Anyone? Otherwise we're giving it to Mashaba. It's going to Mashaba. If Mashaba gets it right, Mashaba, we will send you an e-wallet. You will contact Hasanain and you will get 50 rand. Let's see, what did Mashaba say? 36 comma something. What did Mashaba say? Right, let's go. Okay, so now let's do sin x minus 20. Sin x minus 20. So now you say sin x minus 20 is 90 minus 2x. Sin 90 will always convert the cos to sine. Quiet. Now the sign and the sign cancels out. So here's your two solutions. X minus 20 is equal to 90 minus 2x plus k times 360, where k is an element of integers. Quadrant number 2 minus 20 is equal to 180 minus 90 minus 2x. 2x, 3x, 90 plus 20 is 110 plus 360k, or k times 360. X equal to, Mashaba is coming right here, 10 divided by 3, 36,67 plus k times 120. There we go, Mashaba. Well done, Mashaba. Mashaba, you will get the 50 rand. We'll contact Hasanain and Hassan will send you 50 rand. Give him a nice round of applause. Well done, Mashaba. Well done, Mashaba. Right, let's do the next one quickly and we go for break. We got 2 minutes left. Here's it here at the end. X minus 20 is equal to 180 minus 90 plus 2x plus k times 3. Let's solve for x. X minus 2x is minus x. 180 minus 90 is plus 20. 110 again. Plus so x is equal to, divide by negative, minus 110 minus k times 360. You'll get 3 marks there and 3 marks here. This question will be 6 to 7 marks and maybe 1 mark there. Total marks 7. Right, boys and girls. Mashaba, well done. Everybody, well done. Onliners are on time. Like clockwork. Precision clockwork. It's 12:30 on the dot. We resume at 1:20. 1:20. We resume at 1:20. Boys and girls, enjoy your lunch.
And that is how we come to an end of our grade 11 Maths paper 2 live at Al-Falah College in Durban. My name is Khalid Kungane Kivaspati, of course, at the Awqaf SA Cape Town studios. Now we are taking a lunch break where all of our students, including those who are online, you are giving them a break up until 20 past 1. And then we will return to do the final session. The first session and the second session, of course, have come to an end now. We will have a lunch break. So we advise the students, those who are joining us online and those who are on site, of course, to take a breather and then we will be back. It was quite a fascinating segment that we've got here, especially the second segment, whereby we saw students like Siabonga Mashaba who were like buzzing with the mathematics that was presented there by Mr. Khota. It is nice to see that students, are engaging with the facilitator, because it shows that there's a relationship, there is a sense of understanding of whatsoever the educator or the facilitator is putting in front. So we do encourage all other students to make sure that when the facilitator is busy facilitating, they do engage, they do ask those questions, and they try and make sure to sort of give the facilitator a picture that they are part and parcel of the workshop as well. So if you are a person maybe who's quite impressed with the work Awqaf is doing, because knowing very well that these workshops are absolutely free. But Awqaf do need the funds, in order to try and make sure that they expand, the network when it comes to these workshops. And what we have done is we have sort of made it easy for anyone who would like to support this platform by donating. There's a QR code on the screen, of course, where you can scan the QR code, or you can even take the picture of the QR code, so that when you do possess those funds, you don't have to go to our YouTube and look for the part where the QR code has been displayed on the screen. You can just go to your pictures, and then you can take the QR code there and scan it and support these sort of workshops that Awqaf is putting in front of everyone, at the disposal of everyone who would like to access these. This platform is not just for students, as we have been making mention that there are also teachers who join these platforms, in order to look at methods, of teaching the students, or portraying the message, or to look at different solutions. Because as one of the students made mention yesterday, she made a very, very important point, that it's important, at times, to, even if you know something, but to get someone new presenting something you already know, but it also gives you, different methods of facing the same challenge. Of course, if you're joining us now, we have just taken a lunch break. The Awqaf SA Maths Workshop is coming live from Durban. We are doing the grade 11 paper 2 from Al-Falah College in Durban, KZN, in the Republic of South Africa. So if you'd like to do revision, perhaps of whatsoever has been done here, or you just came late, do not worry, do not despair. The segments will continue after the break at 1:20. And when it goes off, maybe you missed the trigonometry, then you can go to our Awqaf SA Facebook or YouTube page, and you can sort of get the stream there, and you can go on and do revision on whatsoever you do need to do revision on. We will be back here at 1:20. We hope to see all of you at 1:20. We are having quite a lovely session here. Everyone is engaging very well, and hopefully by 1:20, all of you will be here with Mr. Khota doing that third and last segment of the grade 11 maths workshop. And in the coming week, we will be looking at grade 10 as well. So if you are doing grade 10, do not be despondent, because we also have a solution for you in the coming week. So we need to make sure that we are on the site, and as well join online for those whom it is impossible to join on the site. So we need to make sure that we're engaging with the facilitator at all times. And that's where we come to an end as for the second segment of this workshop. And we hope to see you at 1:20, inshallah.
How's it? How's it?
And those, of course, are the students at Al-Falah College with Mr. Khota there, having a light moment, sharing the jubilant mood that is around there. As we said earlier, that we are quite pleased and we are happy that students will gather and sing, together, because it shows the positive mood. No one will come and sing along if the mood is not so high. And we are glad that the mood is the way it actually is. And it is, the mood is like that. This is no athletics, this is no wedding, there's no graduation or something like that. But it's the maths workshop, and it's something you love to see. You love the energy. And if you are wondering what's going on, we have now taken our lunch break, which signals the end of the second segment out of three segments. And then we're coming with round three at 1:20. So stay tuned. In case you've just joined us, this is Awqaf SA, grade 11 maths paper 2, the second day of the workshop. If you remember very well, yesterday we did grade 11 pure maths paper 1. So do stay tuned. At 1:20, Mr. Khota will get the things going. We hope to see you at that time, inshallah. So that's where I will leave you for now. Assalamu alaikum wa rahmatullahi wa barakatuh. It's 20 past 1. Now we will resume with Mr. Khota for the third segment of today's workshop, where we are busy doing grade 11 maths workshop paper 2 with Mr. Khota. Mr. Khota, take it away.
Welcome back. Learners, online learners, are you still there? We're now going to be doing trig graphs. I want to do trig graphs and 2D trigs, so let's just have a look at this, what we have. Okay, welcome back. Onliners, are we there? Hit us up in the comments in the chat session. I hope you guys enjoyed your lunch. We're starting with 2D trigs. Shout out to Mashaba. Welcome, welcome. Tokoza Promise, we are here. Right, grade 11s, let's go. Let's get started. We are back in the program. Please call the learners from outside. Let's get busy. Right, here goes. Shh. Grade 11s, I need silence. The learners that are walking in, you need to be settled. Grade 11.
We thank you for joining us at Awqaf SA Maths Workshop, grade 11, coming live from Al-Falah College. We are experiencing a few technical issues there. We hope as soon as we can fix that, we will be back live with all of you to begin our third segment of our maths workshop with Mr. Mohammed Khota, live from Al-Falah College in Durban. Hit us up on the comments, let us know what is going on. A lot of people in the comment section, they are talking to us, they are chatting to us, and we see Mr. Khota as well. Is almost back. He is.
Thank you, thank you, thank you. Okay, let's get started. We're starting with non-90 degree triangles. Put the heading there, non-90 degree triangles. Is what we call the area rule. So area is equal to half of a sound, half of a side times another side, sine of the included angle. Grade 11s that are walking in, please, you need to settle down quietly. Shh. Guys, we are in session. Thank you. Shh. Boys, thank you. Right, let's take a triangle, any triangle, and I give you an angle here and I tell you that angle is 40 degrees. I tell you this is 50 units, that is 80 units, that is 100 units. Find the area of triangle ABC. Shh. Find the area of triangle ABC. Now guys, this is your baseline knowledge. From the baseline, we're going to take you into exam style questions. Grade 11s. Guys, there's too much talking here in the hall. Okay, here we go. Find the area of triangle ABC. Now remember, area is half of a side times another side times sine of the included angle. So if we're looking at that angle there, if we are looking at this angle here, we have to look at the 50 and the 80. We don't look at the 100 at all. So take this one down. Area is equal to half of 50 times 80 sine 40. This is your included angle between the two sides. So we have to use the 50 and the 80. We don't use the 100 at all. Shh. Right, on-site learners. On-site learners. Right, let's go. Let's work this out. A half of 50 times 80. So 50 times 80 divided by 2 times sine 40. We get 1285,6 unit squared. There we go, a non-90 degree angle. So just remember this formula, onliners and on-siters. Half of a side times a side times sine of the included angle. I'm not going to wait for everybody because I see a lot of learners that just walked in late. So you're holding up the entire program. Onliners, how are we doing? 1285,58, fantastic. Olwetu, Michelle, well done. Right. Now we're going to do the sine rule and the cos rule. We're going to revise the sine rule and the cos rule. And then we're going to apply it. Thank you. Grade 11s. Okay. So there we go. We done the area rule. We're now going to do the sine rule and the cos rule. Now you've walked in late. The sine rule. Right. When we use the sine rule to solve triangles, to solve non-90 degree triangles, find angle okay. Use the sine rule. So I'll give you triangle PQR. Let's make that 60, let's make that 80, and let's call this 35 degrees. Thank you. There's a lot of learners that have just walked in late. You need to settle down quietly. Thank you. Here we go. The sine rule we use when two sides and the excluded angle given. angles and any one side. Right, here we go. It's a ratio. We're looking for an angle here. So we're going to say sine P over 60. So sine of an angle over any side is equal to sine of any other angle over its opposite side. So what you want to do is you want to have it unknown over known equals known over known. And you want to solve for the unknown. Thank you, grade 11s. The boys at the back, there's too much of talking. Shh. Quiet. Right, let's go. We're solving for the unknown, so sine P is equal to, we multiply this side by 60. We multiply by 60. We're going to get 60 sine 35 over. You use the shift key on your calculator. Shift sine fraction 60 sine 35 over 80. 25,47, 25,8, 25,8 degrees. Right. There we go. So I'm just showing you how to apply the sine rule. We're now going to do the cos rule. In fact, let's do two angles and one side. We did two sides and one angle. In this case, we did two sides and the exterior angle. Let's do one with two angles and any one side. I know this is easy work, guys. Thank you so much, Banele and Olwetu. Thank you, onliners. Right. Here we go. Let's do another one. I'm erasing this diagram. We're still going to be a triangle. Let's call this triangle PQR. We want two angles and one side. Let's call this 100 degrees. Let's call that 40 degrees, so two angles. And any one side, let's call this 50. 50 units. Or 50 meters. Take this diagram down. It's important. Right, the question says solve for x. Thank you. Thank you. Right, let's go. So two angles and one side is given. Side over sine of its opposite angle, x over sine 100, equal to any other side over sine of its opposite angle. So now, there we go. Unknown over known is equal to known over known. X is equal to, we multiply this side by sine 100. What I do on the left, so we get 50 sine 100 over sine 40. So x is equal to, let's go calculators guys, 50 sine 100 divided by sine 40. 76,6 meters. So x is equal to 76,6 meters. There we go, done with the sine rule. 76,6, mashallah, well done. Well done, well done, well done. We're now going to do the cos rule. So the sine rule, we use it when two sides and the excluded angle given, or we use it when two angles and any one side. Okay. Now we're going to be doing the cos rule. Now pay attention. Now we're going to be applying the cos rule. The cos rule in any triangle ABC that the last side squared is equal to the other two remaining sides squared. Like Pythagoras, but there's no 90 degrees. So minus 2 times the product of those two cos of the angle. So let me show you how it's done. We use the cos rule when two sides and the included angle is given, or we use it when sides are given to solve a triangle, a triangle. So to give you an example of that, let's make up one. You need this for grade 11 and 12. There's still too much talking here. Okay. If I tell you that is 100 units, I tell you that is 80 units, and I tell you that this is 37 degrees. This is triangle KPM. Find KM. Side squared. The side opposite your included angle squared. So KM squared. Now we're done with that. We only work with these three values. Two sides and the ink's a C. Can you see what alphabet does it make? Using these three letters on the right hand side, what alphabet does it form? So it's the cos rule. Can you see? Shh, pay attention. So Km squared, the last side squared, is equal to 80 squared plus 100 squared into 80 into 100 cos angle. So Km is equal to the square root of 80 squared plus 100 squared minus 2 into 80 into 100 cos 37. Km is equal to, right, let's go to our calculator. Square root 80 squared plus 100 squared minus 2 into 80 into 100 cos 37. We get 60,18. which is approximately 60,2 units. Right. Let's see. Our onliners, probably some of them got it already. 60,2, 60,2, 60,2 all the way to, how did you get 100,05? Yes, Banele. Myself and Banele get 60,2. Precious, how did you get 100,05? 60,18, 60,2. Right. Now let's give you a diagram. So the one that's from your past paper here, all right, this is interesting. Let's start with this one. I'm clearing here. I hope you all got this. Right. Are you done? Guys, take this diagram down. Take this diagram down. We got that. We got this. We got that. This is, they tell you the angle of depression here is angle theta. This is triangle P, Q, R, S. This is X. That's alpha. That's beta. Right. That is parallel to that. Question number 1. Find QR in of X alpha beta. Question number 2. Find H, the height, PR. Find PR or H in terms of X, theta, alpha, and beta. Find the area of if X is equal to 60, alpha is equal to 20 degrees, beta is equal to 42 degrees. Right. Here goes. So basically we're answering question number 1. They want QR. They want QR in terms of alpha and beta. That means we need to start with that triangle, triangle QRS. So let's go. At the bottom, the answer to question number 1. So in triangle QRS, they want QR. Right. Is this a 90-degree triangle or non-90-degree triangle? Non-90-degree triangle. So we're going to be using the sine rule. So QR over sine of its opposite angle over sine beta is equal to another side x over sine alpha. I want QR on its own. So times sine beta, QR is equal to x sine beta over sine alpha. And there we go, you'll get your first 3 marks. Simple, they're just testing whether you know the sine rule. Guys, I beg you, learn this. Once you get it here, you'll know it for grade 11 and 12. Big shout out to Zianda Twele. How you pronounce it? Twele. 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 Okay. Siabonga 8 sine beta theta tan theta over sine alpha. Yes. Okay, well done, well done, well done. Mashaba is on fire here. Number 2. Right. Now that I got QR, quiet, I need PR for question number 2. So question number 2, if this is quiet, if that is angle theta, then that is angle theta. Alternate angles. Angle Q is equal to theta. Alternate angles. Quiet. Now, in triangle PQR, in triangle PQR, it is a 90. So we use Sokotoa. That's our opposite side. That's our hypotenuse. This is our adjacent. So I need PR and QR. I need O over A. I need O over A. PR over QR. So that of theta. According to Sokotoa, opposite over adjacent theta is equal to PR over QR. Opposite over adjacent. The QR on its own, H on its own, so times QR, so PR is equal to QR tan theta. Quiet. Pay attention, take this down. I'm not doing this one again. PR, therefore PR is equal to, instead of Q, to say, what did we find the last one to be? X sine beta over sine alpha. That was QR tan theta times tan theta. And there we go. That's your answer for question number 2. So X alpha beta theta. There we go. We've answered it. Shh. Now remember, QR is equal to X sine beta over sine beta. Oh, I gave you X. Oh, beta is 42 degrees. So X is 60 over sine alpha. Alpha is 20 degrees. So what is QR equal to? Let's go to our calculators. I'm answering question number 3. 60 sine 42 divided by sine 20. 117,38, 117,4. 117,4 meters or units. So this is 117,4. What is x? X is 60. So they're telling us that x is 60. This is interesting, this last one. X is 60. This is 117,4. They want the area of triangle QRS. Now, do I have alpha? Now we got alpha. Alpha is 20 degrees. So there we go, that's 20 degrees. Beta is 42. How much is angle R? So now I'm answering question number 3. In triangle Q, angle R is 180 minus t plus 42. Sum of angles of triangle. So angle R is equal to, let's go to our calculator, 80 minus 20 plus 42. 118. The angle here is 118. Therefore, of triangle QR is equal to half of a side, 117,4, times another side, times 60, times sine of the included angle, 118. Let's go to our calculators. 117,4 multiplied by 60, divide that by 2, multiply by sine 118. 3109,74 units or meters squared. Anybody? Yay! All the way to 3109,21 or 74. No problem. As long as you got 3109. Well done. Well done, all the way to. Now let's take the one that they gave us here and let's see if we can crack that one. Here goes. From a past paper, guys. From a past paper. Onliners, how are we doing? Are you still logged on? Beautiful Banele. Lovely. Let's clear this. Let's go back here. Let's give you one from a... Okay, let's take this one down. Take it down with me. They give you that. They give you this. They give you that. They give you this. They give you that. One will be 90, one will be non-90. Triangle A, B, C. This is 135 degrees. This is D. This is 121 meters. Is P over 2. This angle is angle P. And that's it. Shh. In the figure below, ABC is drawn, AB is perpendicular, ACP equals P. CB is equal to 3 of AB. Question number 1. Find the value of P correct to 3 decimal places. Find the value of P correct to 3 decimal places. Question 2. If P equals 18,4, so basically they're telling us what P is 18,4. Find the length of CD. Let's go. Shh. Quiet. Here we go, guys. Remember something, the only thing we need to keep in mind, listen. Shh. The only thing you need to keep at the back of your mind is for a 90-degree triangle, we're going to use SOHCAHTOA. And for a non-90-degree triangle, we're either going to use the sine or the cos rule. That's it. That's the only two tools that you need to know. So where was the question here? There we go. All right, let's go. Shh. CB is 3 of AB. So if that's one line, then CB is 3 lines. Shh, quiet. And we know that this angle is P over 2. That's P over 2. Let's see. Find the value of P. Find the value of P. That over that. Find the value of P correct to 3 decimal places. Find the value of P, that angle there. So they want you to find the value of the angle. I'm just trying to think here. They don't give you anything else, no. That squared that's squared this one looks a bit hectic. I don't know what I'm doing here. Find the value of P. Maybe I'm not seeing somewhere. Anyway, let's go. This over sine that will equal to that over sine that. But that's not going to help me. I don't need CD. I just want to see that I've taken down everything. Triangle ABC is drawn. ACB is equal to CB equals that. ACB is drawn such that DCB is equal to that. AB is equal to that. Find the value of P. Let's see. They gave us a bit of a brain teaser here. If I go 10, 10P is equal to that over that. Then that means then I'll have that. Now if I come into this triangle, if I call that one x, just for example, then this one here would be 3x. What is this angle? I just want to see something. If I complete that, that would be 180 minus 135 plus P over 2. Sum of angles of a triangle. So then we got that. So that side squared okay, we know what the answer is going to be 18,4. My goodness, I'm not seeing this. But anyway, let's try it. Okay, tan P is that of, wait, I think I got it. If I look beautiful, I got P, guys. I got it. Right, look here, let's look at triangle ABC. I'm answering question number 1. How come I didn't see that? In triangle ABC, tan of P, that's my reference angle, tan P is equal to AB over BC. Right? Opposite over adjacent. So tan P is equal to, I call that one BC 3x. So x and x will cancel. So tan P is equal to 1 over 3. Shift tan a third. Shift tan 1 over 3. Ha 18,4. They can't beat us. Maths is dead. We can't let a dead thing beat us. 18,4. So they, no, 18,4 P is degrees. 18,4 degrees. Right. Find the length of CD. Okay, let's see. Easy. Now we're going to be using the sine rule. In fact, we didn't even need this D. I just completed D just for fun. Actually, you didn't even need to do this. It's not required. Right, find. Let's find CD. So now, I'm going to find CD. I'm answering question number 2. CD over sine P over 2 is equal to 121 over sine 135. I'm applying rule. So CD over sine, we just found P, 18,4 over 2 is equal to 121 over sine 135. Let's go back here. So CD is equal to 121 times sine 18,4 divided by 2 is 9,2 over sine 135. So CD is equal to, let's go to our calculators, 121 sine 9,2, grade 11s. Sine 9,2, close brackets, Divide that by sine 135. 27,35, 27,4 units. And here, you'll get 3 marks here, you'll get 4. 4 and 3, 7 marks. Shh. Let's see onliners who got it. 27, Yebo, Michelle, Banele, Angel. Well done, well done, well done. Absolutely amazing. You guys are on fire. Okay? So there we go. This is how we do our two-dimensional trigonometry. Let's go into trig graphs. Okay. We're going to do trig graphs for about 10 to 15 minutes and then we're going to do Euclidean, some application. Guys, I'm not going to teach you the laws that your schools taught you already. The theorems for cyclic quadrilaterals, your schools have taught you already. I'm just going to be doing from the past paper application. Let's start off with some trig graphs. So let's clear here. Right, pay attention. F of x is equal to 2 sine 2x. P of x is equal to 2 cos x minus 30 degrees, for x being an element of minus 90 to 360. Question number 1, sketch both graphs. Number 2, I want the amplitude of G I want the period right for which value of x is f of x equal to g of x and f of x less than g of x and g of x less than 0, less than or equal to 0. So here we go. I'm only going to do one model here. I'm only doing one exam model. So this one here is with a period shift as well as, right. This entire graph shifts. Now watch here. Take this one down. Take this one down and let's apply. Let's go. The first thing we need to do, please pay attention. Grade 11s, you need to learn this. So, let's draw our graphs. Your axis, that's your y-axis. That's your x-axis. That is 0. That's 90. 180, 270. Right, pay attention. And maybe question number 5, they want the domain. Of f. Right. Or the 2 sine 2x. So it will go up to 2 and down to minus 2. Guys, you need to pay attention if you want to master this. It's a sine graph. So sine graph starts at 0. S for sine, S for start at 0. Pay attention. The step of your graph is degrees divided by this number. So is 45. That means that change every 45 degrees, not every 90. Pay attention. It's positive, so it's going to go 0 up. 45, 90, 135, 180, 225, 270, 315, 360, minus 45. So it's going to go up. Instead of it turning at 90, remember you use this formula to calculate the step. 90 degrees divided by that number is equal to the step. So the step is every 45. So it goes up, 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 turn at 45, cuts at 90, turns at 135, turns, continue the pattern on the opposite side, and stop. Right, there we go. This is graph F. Are we all okay with that? I'm answering the first question where we're sketching. Just remember, S for sine, S for start at 0. Now let's do the cos graph. Right. It still goes up to 2 and down to minus 2. It's a cos graph, so it cuts first. So it starts at the height and it cuts. But be careful. It's moving 30 degrees to the right. So instead of it starting at 0, it's going to start at 30. 30, 60, 90, 120, 150, 210, 240, 300, 330, 360, minus 30, minus 60. Now be careful. Now instead of the graph starting at 0 and 2, it's now going to start at 30 degrees. So it's shifting 30 degrees to the right. So it cuts first. The cos graph starts the amplitude. Right. Instead of it coming down and cutting at 90, it's now going to come down and cut at 120. Instead of it comes down, cuts at 90, turns at 180. Instead of it turning at 180, 180 plus 30 is 210. Instead of it cutting at 300 here on the top at 270, it's now going to go at 300. So here goes, watch here. So we come down, 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 down. We cut at 120. Supposed to cut at 90, but it's shifting 30 degrees to the right. Coming down, supposed to turn at 180, but it's now turned 10. Remember, that value there is 120 on my x and 0. Value here is 210 on my x minus 2. Instead of cutting at 270, it's going to come up and cut at 300. It's going to go up to 360. So this value here is 300. Right. Now you're going to come down here. Instead of it, if it had to start here and go and cut at minus 90, 30 degrees to the right, so now at minus 60. So it's going to come down here, minus 60. That's minus 60 and this is graph G. So there we go, we've drawn the two graphs. We've drawn the two graphs. Job E Junior, where the graph starts is 30 degrees to the right. It will cut. So first you draw to the right, then you just continue the pattern on the left-hand side. Right. The next question, the amplitude of G. The amplitude, the maximum height. The answer is 2. The answer is 2. The period of F. So now to get the period, remember it's 2 sine 2x. For you to get the period of the graph, you say 360 degrees divided by that number. 360 divided by 2 is equal to 180 degrees. So the period. To get the step, you say 90 divided by that number. To get the period, you say 360 divided by that number. Now here we go again. Watch here. Now comes the interesting one. Does f of x equal to g of x? It's worth 6 marks. It is worth 6 marks. So that number, that f of x equal to g of x is general solution. Watch here. Right, so all the points of intersection between minus 90 and 360, that question there. Of x equal to g of x. So let's go here. I'm clearing that. F of x was equal to 2 sine 2x. X was equal to 2 cos x minus 30. Element of minus 90 to 360. There's a lot of... Right, so here we go. So f of x, so basically, points of intersection. Thank you, grade 11s. 2 sine 2x must equal to 2 cos x minus 30. Divide by 2. Sine 2x equal to sine 90 minus x minus 30. Before break, we did one like this. Guys, do you remember before break, general solution, we did one like this. We had to change the cos to sine. Pay attention. Thank you. Sine and sine cancels out. 2x is equal to 90 minus x minus 30, or 2 equal to 180 minus 90 minus x minus 30 plus k times 360. Pay attention. X is equal to 90 minus x plus 30 times 360, blah, 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 blah. X3x is equal to 90 plus 30 is 120 plus k times 360, where k is an element of integers, equal to 120 divided by 3, 40 degrees plus k times 120. Now do you see the purpose of doing general solution? Now we go 2x is equal to 180 minus 90 minus x plus 30 plus k times 360. Guys, I'll wait for you. 2x is equal to 180 minus 90 plus 30 is 120 minus x. Remove 2x minus x is equal to 180 minus 60 degrees. But these are our general solutions. We still need to find the points of intersection. This is where you start substituting your integers. So the problem is long. It's worth 6 to 8 marks. Shh. So now, listen. Now you need to put in all your integers 0, 1, 2, minus 1, minus 2, 0, 1, 2, minus 1, minus 2 for k, and whichever your answers fall within minus 90 to 360, those will be the points of intersection. So let me do it for you. Just to show you. X is equal to 40 degrees plus k times 120. So now you're going to say 40 degrees plus 0 times 120, 1 times 120, 40 degrees plus 2 times 120, 40 degrees minus 1 times 120. So, 40 degrees plus 0 times 120 is 40 degrees. 120 plus 40 is 160. 240 to 80. 40 minus 120 is minus 80. All of these are valid because it falls within your restriction. So, right, so let's just go back here. 40, 160 to 80 minus 80. Let's just check. Where was... so we can clearly see that this one here, the first point of intersection is 40 degrees. Correct. That's your first solution. What's the next one where they meet? Now we go to 160. Now 160 is far there. Where are we going to get this point where they meet? Remember, we're not yet done with our general solutions. You still got 60 plus k times 360. So now you're going to go 60 plus 0 times 360. 60, 1 times 360. That one's out. 60 minus 1 times 360. That one's out. That one. So that means the other point. The points of intersection where they are equal is 60 degree. It's minus 80. We are correct. Let's go back. minus 80. There we go. There's your minus 80. There's your 40 degrees. There's your 60 degrees. We know we are right. This point here is 160 degrees. So we know we are right. And this point here is just after the, so let's go back. 280, we know we're right. So that means your answers are minus 80, 60, 40 degrees, 160, 280. Guys, you have to show all this calculation. They say show algebraically the points of intersection. This is why we have general solution. For you to find out all these various points within a given restriction by substituting your integers. Right, let's just go back. I just want to show them, somebody wants to see the diagram again. Have a look at the diagram and those questions. So here we go. We've answered this question here. Shh. The answer to this question here is obviously minus 80. 60, 160, what was the other one? 280. Where is f of x less than g of x? Where is graph f underneath g? So f, I'm now doing where is f of x less than g of x? Underneath. What point was this? 280. That was 280 where they met. So it's underneath from 280 to 360. So x less than 360 but greater than 280. Where else is it underneath? It's underneath between 60 and 160. So x less than 160 but greater than 60. Where else is it underneath? It's underneath from 45, from minus 60 to 45. No, minus 80 to 45. That's where it's underneath. Where is g of x less than or equal to 0? Where is graph g underneath your x-axis? Where is it negative? From x less than or equal to 360 but greater than or equal to 270. Where else? Between 90 and 180, x less than or equal to 180 but greater than or equal to 90. Anywhere else? Yes, between 0 and minus 90. X less than or equal to 0 but greater than or equal to minus 90. What's the domain? Come on, the domain of both graphs. There's your domain on the top, your restriction from minus 90 to 360. And there we go. It's 2:30 on the dot. We are done with trig graphs from your exam model. Let's now go into Euclidean. Mashaba, let's see. Yes, minus 80 to 40. Minus 80 to 40. Oh yes, it was 40 degrees, not 45. Thank you, Mashaba. It was minus 80 to 40. This point here was 40 degrees, not 45. Thank you, Mashaba. The main brain for today. Beautiful. Beautiful. Ngiyabonga mashaba. Well done, well done, well done. Yes, 8 marks.
MashaAllah, Mashaba.
Mashaba. You must know when the learners are picking up our calculation errors, you must know they are on point, brah. Destination distinction.
Flames.
Must we include 360? Yes, you must. Did I? Yeah, you have to include because it's up to 360 and down to minus 90. Mashaba is drunk. He's drugged with math. Mashaba is drunk on math. Mashaba, we got our eye on you. Mashaba, you get 100% at the end of the year. We give you a super prize from Awqaf. There's cash prizes at the end of the year for the top learners, even for the most improved. So please, guys, you guys need to submit all your marks to Awqaf. Let's see if you clock distinctions, you're going to either get cash money or you're going to get laptops or you're going to get, depending what prizes they give, even cash prizes at the end of the year. Let's go. Let's go. Right, I'm now going, let's take this. Okay. Let's start with one here. Quiet. Take this diagram down. So they give you, that's the center of the circle. O is the center of the circle. They give you that. They give you that. They give you a straight line going up there. They give you a line going across down there. They give you a line coming down there. And they give you a line going across there. O being the center of the circle, that's 1, that's 2. This is H. This is H3, that's 90 degrees. That's 2, that's 1. This is G, that's 55 degrees. That's F, F1, F2. E, E1, E2, E3, that is D. Right. In the diagram below, DF is a diameter. Chord EG intersects, right, chord EF and right, EGF is 55. Right, with reasons, find. Find with reasons, number 2, angle D, angle O2, angle E2, angle E3. Determine the length of OH. Find the length of OH. If the diameter is 10, and GE is equal to 9,4 units. Now, these ones are 2, 2, 2, 2, 2, 3, 4. 2 marks, 2 marks, 2 marks, 3 marks, 4 marks. Total, 2, 4, 6, and 3 is 9, and 4, 13 marks. Quiet. Shh. Now, guys, before we start, some basic laws of circle analytics or Euclidean. You always start from the known, moving to the unknown. Where do you begin? Grade 11s, where do you begin? You start from the known, moving to the unknown. And you use your theorems to back you up. Shh. Your mark allocation tells you also the level of difficulty. So if it's 2 marks, straightforward. 3 marks, it means little bit jigga before you get to your final answer. 4 marks, 5 marks, it means, hey, many off-roads to get to your answer. Quiet. Shh. I'll wait for you. Right. Let's go through our laws. What do we know? Let's see if you remember your theorems from a circle. Picture a circle in your mind. Right, we know. Let's start off with the cyclic quadrilateral. The first law we know that the exterior angle of a cyclic quad is equal to the interior opposite. Yes or no? What's our second one? Opposite angles of a cyclic quad are supplementary. What's the next one? Equal chords subtend equal angles. Angles in the same segment at the circumference are equal. Line drawn from center of circle to the midpoint of a chord always meets it at 90 degrees. Angle at center is 2 times angle at circumference. A diameter subtends a 90 degrees at the circumference. A radius is always perpendicular to a tangent. Angle between tangent and chord is always equal to the angle in the alternate segment, tan chord. And 2 tangents meeting at a common point outside a circle are equal in length to where they meet the circle. Shh. Grade 11s. Right, let's go. Let's find angle D. There's angle D. Now we can clearly see the bow tie. Watch here. Watch here. There. 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 I said start from the known. What's your known? 55. Now you can clearly see angles in the same segment. So how much is D? Fantastic. So the answer to question number 1, angle D is equal to 55. Angles in the same segment. Angles in the same segment. Number 2. Angle O2. So what I'm going to do now, I just want to erase that. Once you get the answer there, go and put it in there, 55. So that's 55 degrees. Now we're done with that. Angle O2. Angle O2. I got it. Did you get it? I have it. Watch here. That side is equal to that side radii. So E1 and E2 is also 55 degrees. E1 plus E2 is 55. Why? Isosceles triangle. Pay attention. That's 55. So now, an exterior angle, if I extend this line, exterior angle is equal to the sum of the interior opposite. But you can't just say it, guys. You have to start it like this. Pay attention. So we're now going to say OD equals OE. OD equals OE. Rate. Therefore, ODE is isosceles. angle E1 is E2 to 55 degrees. Angles opposite the equal sides. Is equal to 55 plus angle D plus angle E, which is equal to 55 plus 55, which is equal to a angle of triangle is equal to the sum of the interior opposite is 110. So we're done with number one, we're done with number two. Guys, we don't have much time. We only got 20 minutes. Shh. So let's do as much as we can. Right. Shh. Grade 11s. Do number 3 and 4. Start with number 3, start with number 4. How's our onliners doing it? There we go. Okay, let's do number E. Let's get E2. Oh, we could have even got E2, and exterior angle at center is 2 times angle at circumference. I was so stupid. I went the long way. Dummy. I took the garden route. For question number 2, you could have said O2 is equal to 110 at center is equal to 2 times circumference. You didn't need to do this long thing here. Let's do it. Where's E2? There is E2. So we got this as 50. Oh, this was 90 degrees, right? H3 was, so now I'm looking at this triangle here, DHE. Find E1. You see how this helped us here. E1 plus E2 is equal to 55. Because this is an isosceles triangle. Or we can see angle E1 plus angle E2 is equal to 55. But angle E1 is equal to 180 minus 90 plus angle D, 55. Sum of angles of a triangle equal to 180 minus 9 plus 55 is 145, which is 8 degrees. So E1 is 35, but E1 plus E2 is 55. So E2, so here we go, E1 plus E2 equals 55. E1 is 35 plus angle E2 equals 55, So E2 is equal. E2 is 20 degrees. 20 plus 35 will give me the whole 55 here. E3. Right, I don't know if you picked this up. E1 plus E2 plus E3 is 90 degrees. Angle E1 plus E2 plus E3 equals. The subtends are 90 degrees. This whole angle is 90. Angle in a semicircle. Much? 35. E2 is 20. Plus E3 is equal to 90. So E3 is equal to minus 55. 90 minus 55, 35 degrees. So angle E3, very good. You guys all picked that up, was 35 degrees. Last one, find the length of OH. Find the length of OH. 10. Diameter is equal to 10 units. That means, quiet, that means the radius is 5. That's 5, that's 5, that's 5. And GE is 9,4. Where's G? GE is 9,4. So find the length of OH. O. So we need this piece. We need that piece, OH. That's 5, that's 5. Huh? No, that whole length is 5. That's a 90-degree triangle. Shh, quiet. Five, I can call that X. That's also 90. Quiet. Thing is 5, OH is 5. Let's call OH X. If the whole length is 5, then OH is equal to 5 minus X. Let OH be X. OH diameter is 10. This whole length is 5. OH is 5 minus X. No, if that is X, then this is 5. That piece there on the top is 5 minus X. Okay. If your diameter is 10, 5, 5, that whole thing is 5. OH on its own is something I'm not seeing here. All right. Let's go. And GE is 9,4. Oh, they told us, I forgot, they told us GE is 9,4. GE is 9,4. So we've got a big line there, and that's 9,4. We've got that whole line there. That's 5. Something I'm not seeing here. That's 35. That's 35. Something I'm not seeing. So we know, if I use Pythagoras here, that would be 5 squared. Let's just check our onliners. Onliners, what do you see? You see stars here. Diameter is 10, so that's 5, that's 5. OH. GE is 9,4. How is that going to help us? 9,4. Oh, I see it. There we go. Watch here. This is GE. GE, that's E, that's G. You got a line, you got O. Line drawn from center of circle perpendicular to the chord breaks the two parts up. So if this is 9,4, 9,4 divided by 2, this piece is 4,7, that piece is 4,7. We've got OE, OE is 5. We need now OH. Right. So I'm just going to be using Pythagoras here. Here's our answer. Shh, quiet. HE is equal to 4,7. Line drawn from center of circle. Degrees to the chord. Bisects the, and OE is equal to 5 radius. Therefore, OE squared is equal to 4,7 squared plus OH squared. 5 squared, which is 25, is equal to 4,7 squared is 22,09 plus OH squared is equal to 25 minus 22,1, 2,9. Therefore, I'm just going to put the answer here on the top. I'm just using Pythagoras. I am just OH squared equals 2,9. So OH is equal to the square root of 1,7 units. Let's see who got that one. Onliners, did anybody get that? I don't see anybody putting up 1,7. I don't see anybody putting up 1,7. Oh, now, oh, very easy. Now they're all putting up 1,7. Oh, well done. Well done. Right. Yo, we got 4 minutes left. Let's see if we can do one quick problem in 4 minutes. You want to try one? Guys, work with the Euclidean, work with your teachers. We've come to the end of the session. We've got 3 minutes left. I just want to say thank you all for attending. It's been an absolute pleasure having you guys for 2 days. I'd like to also say thank you to the Department of Education, Awqaf South Africa, Thread Awqaf, iSkill, Hasanain, you and team have been amazing feeding up all the comments. 10,000 learners. You guys have been absolutely amazing for 2 days. Travel safe, much love, and inshallah we hope to see you guys again at the end of the year. Jazakallah so much, Hasanain.
Thank you so much. That's where we conclude. Any final remarks, Mr. Khota? You definitely brought the fire, you brought the tears today. How are you feeling after 2 days of awesome grade 11 maths?
Jazakallah so much. Hasanain, it's been absolutely amazing as usual. Looking forward to next week. I'm looking forward to Cape Town grade 10s next weekend. And Jazakallah to Zafar and Al Falah College for allowing us the opportunity to broadcast here from KZN, and to Awqaf South Africa for the amazing amount of work that was put in to make this project possible. Also Jazakallah and thank you to Mr. Kathri for the amazing sound, putting this all together and spending the complete 2 days with us. Been amazing experience as usual, and looking forward to coming back to KZN in September. From my side, from Mohammed Khota, Jazakallah, lots of love. Time to love you and leave you. See you guys. Good luck, God bless, and get that distinction. Jazakallah.
There we go. That's where we conclude the Awqaf SA Grade 11 Maths Workshop, coming to you live via Awqaf SA's YouTube platform, and Mr. Khota beaming that from a very lively, energetic, and very interactive crowd there from Al Falah College in KwaZulu-Natal. I think you, as the participants, you deserve a round of applause. So that's a round of applause from myself and Khalid to you. We really appreciate you being today, interacting with us. I think with your dedication and with your hard work, you'll definitely be acing your maths examination. So I would like to take this opportunity to thank one and all the Department of Basic Education, the Al Falah College in KwaZulu-Natal, Durban, as well as the principal, Mr. Zafar Ahmed, Rakesh, and all of the support staff. I would like to thank the Thread Wakaf, iSkills. These are all some of our partners. And this session would not have been possible without the technical genius of Faisal Kathri and his team. We really appreciate your craft. So he assisted us, Mr. Kathri from Kathri Sounds, for the AV and technical. Mr. Khota, you deserve a round of applause. This was an awesome session, and I'm confident that this session benefited our grade 11 learners. I would like to thank Khalid for assisting us with the continuity, pressing the buttons there at the back. We really appreciate your dedication. You definitely brought some gears, and thanks also. It was really good interacting with you during the break time when we had time to speak to some of our learners. Any concluding remarks on your side, Khalid? How did you find the session today?
The session was intense. The session was intense, and I must say that Jazakallah khair to you as well, Hasanain. Your input behind the scenes. Every time we run, we've got those technical glitches. We've got a shoulder to cry on, and it is absolute pleasure to work with you. And I'm quite happy, when you've got these sessions, the preparation that goes, with having these sessions and then actually to deliver these sessions to the med students, it's a huge task, and Awqaf has been doing this now, and all the time it becomes successful. The work Mr. Khota puts in when you interview the students, when you get to talk to the students and you get a feel that they do enjoy these sessions and they just feel at home. So overall, this weekend, I would say that it was an amazing weekend, and we are quite happy with the work Mr. Khota is doing, and we are stepping on the right direction.
There we go. So we spoke to Michelle from Soshenguve, Mr. Kota. She had good to say. I think we got another Rory sang in the making, another 100%er. So yes, just some
Just
final
some
remarks
final remarks
from your
from
side.
your side. Yes, I cannot thank the learners enough, our onliners as well as our on-siters for their amazing contribution. All way to, I'm just going out to some of them. We got Michelle, we got all way to. I must also say a big shout out to Mrs. Furi or Miss Furi from Cape Town, who's been full part of the entire program. She's been absolutely amazing. Bombi, Nkosi Mandla, Ipaputsa, Chekofatso. These were the ones that were really Banele, Mashaba. Where's Mashaba? Siabonga, Mashaba, Ntando, Bombi. They've been through Michelle Ramutla, Tato. Wow, Olwetu. You guys have just been absolutely amazing, keeping the momentum going and keeping this program. Without you guys, Bombi, bye. Really, without you guys, this program couldn't have the impact. It's really important that we have all this consistent interaction with the learners so that we know that they are still logged in. And these comments, talking to us live, and all these live feeds coming in one at a time really gives us the motivation and the drive to give you 10 times what we needed to deliver.
So there we go.
Big shout out to all of you. Lots of love.
Okay, Mr. Kota. Signing out. So please bear in mind these sessions are hosted on Awqaf's YouTube platform, so you can refer back to these videos. We will see you in October, and that's where we leave it off. All right, for myself, Khalid from the Awqaf SA Cape Town studios, that's where we end it off. Assalamu alaikum wa rahmatullahi wa barakatuh.
In the year 2000, Awqaf South Africa was pioneered as an institute of Awqaf and the empowerment of communities. South Africa faces a diverse set of challenges with a high unemployment rate and a stark divide between rich and poor, where electricity, hospital care and water shortages plague communities and where lack of education hinders progress. Awqaf South Africa is a catalyst for change. As a charitable endowment receiving organization, Awqaf invests endowment funds wisely and ensures that only the income generated from investments is used to fund a variety of community development projects. We are excelling in all that we do with the highest standards of ethics, integrity, and sincerity of purpose. From masjid development, imam empowerment to sports development, orphan support, food security, and surgery support, Awqaf South Africa is paving the way by investing in the future of communities and uplifting generations to come.